Over the next several hours, I'll take you step by step through the process of building a blog platform using Spring Boot and Spring Security. This project sits somewhere between beginner and intermediate and would be approachable for a beginner as your second or third project. Now, if you're looking for your first project, then I'd recommend checking out my task app builder, and I'll leave a link to that up here somewhere. Now, in this project, we're going to focus on adding JWT authentication with Spring Security, using Project Logbok, and using Mapstruct. And we're going to implement the project following this plan. We'll start by analyzing the project brief. We'll then move on to designing the implementation. We'll set up the project, and then we'll create the JPA entities that we will need. We'll then create the JPA repositories, implement the category endpoints, add Spring Security. We'll configure Spring Security to use our user entity, and then we'll add a JWT authentication endpoint. We'll then add a JWT authentication filter, implement the Tag Endpoints, implement the Post Endpoints before wrapping up the project. You can find the lesson write-ups, the project source code, and the React frontend that I'm using all on the Devtiro community site. You can join for free, and there is a link in the description below. Now, if this is your first time here, welcome. My name is Aaron Bourne, and I'm a software developer with over 15 years of experience. And I'm here to help you learn Java, Spring Boot, and all those related tools. So, with all that covered, let's get started. In the upcoming lessons, we'll be focused on building an application rather than discussing the theory in detail, so a foundational knowledge will help you to get the very most out of this project. To follow along and build the blog platform app, you'll need a practical knowledge of Java, Maven, Docker, and PostgreSQL. By working knowledge, I mean that I won't be explaining how these technologies work in our project. I'll assume that you're already comfortable with them, so we can focus on building our application. If you're not so sure, I'll leave some resources in the description below which will help you get up to speed. Now for Spring Boot, you should already be comfortable with the basic concepts. If you've taken a beginner's course on Spring Boot, then you should be set. Now where this project becomes a little more challenging is that we're going to be using Spring Security and JSON Web Tokens, otherwise known as JWTs. So a basic knowledge of Spring Security and how JWTs work would be very beneficial. Although it won't be strictly needed, as once our security is configured, we'll not need to revisit it. Now a special note on our project's React frontend. Of course, this project is focused on building a Spring Boot application. However, I do offer the same React frontend that I use for you to download. We'll be using the Node Package Manager, or NPM, to install the dependencies that we need for the frontend. So although you don't need to know how Node works or how to build a React application, it would be very beneficial to know what Node is and what it means to use NPM. Otherwise, a quick read of the Node website should be enough to understand this. So with that covered then, in the next lesson, we'll look to set up our development environment. So let's set up our development environment. To build the blog application, you're going to need the Java Development Kit, or JDK, version 21 or later. You can check the Java version by opening up a terminal or a command prompt and typing java-version. You can see here I'm running version 21.0.5. If you see an earlier version, then I'd recommend heading over to oracle.com to download JDK 21 or later. Or if you prefer an open source JDK, then you can download it from Adoptium, which is part of the Eclipse Foundation. As long as it's version 21 or later, either JDK should work fine for this project. We'll be using Apache Maven to manage our project, although you'll not need to install this on your system, as an instance of Maven will come bundled with your skeleton Spring Boot project, but more on that later. To run the PostgreSQL database we'll be using later, you'll need Docker installed on your machine. To check that you have Docker installed, open up a terminal or a command prompt and type docker --version. You should get a version number printed out, otherwise head over to docker.com to download Docker. To run the front-end code, which I'll provide, you'll need Node version 20 or later. You can check the Node version by opening up a terminal or a command prompt and typing node --version. Again, note that it's 2 hyphens in front of version for Node, just like Docker, but unlike Java, which only uses a single hyphen. So again, you should get a version printed out. Now, if you don't have version 20 or later, then I'd recommend heading over to nodejs.org to download a later version of Node. Now, for my IDE, I'm going to be using the community version of IntelliJ IDEA. You can use any IDE that you like, such as Visual Studio Code. However, I recommend IntelliJ as it's brilliant for Java development. You can download the community version of IntelliJ for free from the JetBrains website. So with everything installed, let's check out the requirements of what we're going to be building. Let's review the requirements of the blog application that we are to build. The project brief itself can be found on the Devtiro community site. If you don't have access yet, then I'll leave a link in the description where you can get access. If you can't join for whatever reason, no problem. I'll be showing you all the requirements right here anyway. So once you're logged into the community site, if you scroll down here and then go to project briefs, you come to this page here. And if we scroll down a little bit, we can see the blog platform. So let's click on this and let's expand this. So the project brief itself is broken down into a few different sections. So we have a summary at the top, some definitions next, and then some user stories and some acceptance criteria. So let's go through this from the top. So the summary is just a high-level overview of the application that we are to build and the problem that it solves. In this case, we can see the blog platform is designed to provide users with a space to share their thoughts, experience, and expertise through written content. And the platform will offer an intuitive interface for creating, managing, and publishing blog posts. So all of the things that you would expect from a typical blog application. If we scroll down a little further here to the definitions, let's go through these. So to start with, we have the definition of a post. A blog post is a piece of written content that includes a title, body text, optional images, tags, and publication date. And then we learn that posts can be drafts or published articles. Images aside, because we won't be dealing with images in this build, this is a great piece of information for what goes into a post. Title, some body text, tags, publication date, and then we have a status here of draft or published. So let's move on to category next. So we can see a category is a broad classification used to organize blog posts into main themes or topics. And we can see some examples: technology, travel, personal development. So the relationship between the two is that a post belongs to a category. It must have a category. So when you create a post, if the topic is on technology, then you would select the technology category, travel category, personal development, so on. And of course, you can create categories as you like as well, but we'll get to that in a moment. So broad classification, that's our category. So let's move on to a tag next. And this is a specific keyword or phrase that describes the content of a post in more detail than categories. So a tag is similar to a category, but we can see here, unlike categories which are broad groupings, tags are more granular and flexible. And a key piece of information here, a single post can have multiple tags, whereas a post can have only one category. A key difference between a tag and a category there. So now that we've got our definitions, let's move on to our user stories. If you're unfamiliar with this pattern, a user story describes what a user wants to do from the point of view of that user. This little nuance is enough to give us some additional context over the system must do X or the system should do Y. And of course, more context helps us to make better decisions during development. So let's take a look at this first user story here, content creation. As a writer, I want to create and edit blog post with a rich text editor so that I can express my ideas effectively with proper formatting. So we can see here the user in this case is a writer, wants to create blog post with a rich text editor. Now, following the user story, we have some acceptance criteria, and these are statements which can be either true or false. And the idea is, once all of the acceptance criteria evaluate to true, then this user story is complete. So let's go through these. Users can create new blog posts using a rich text editor. Currently false because we haven't built our application yet, but once our application is built, we can make this statement true. We want the editor to support formatting options such as bold, italics, headings, and lists. Posts must have a title and content body. This is important to give us an idea as to the structure of a post. Users can edit existing posts with all changes being saved, and users can delete posts with a confirmation prompt. And finally, posts should display an estimated reading time. So we can see here we have 6 acceptance criteria in addition to the user story, and they're all based around the concept of posts, creating posts, editing posts, managing posts, etc. So let's move on to our next user story. And this one is around content organization. So as a content creator, that's our user this time, I want to categorize and tag my posts so that readers can easily find related content on specific topics. So this user story is all about categories and tags. So the acceptance criteria here, users can assign one category to each post. Users can add multiple tags to each post. Users can create and delete categories. Users can create and delete tags. And the platform displays category and tag counts. So that's to say how many posts have that tag or are within that category. So that's content organization, so categories and tags. Let's move down to draft management. As a blogger, I want to save drafts of my posts so that I can work on content gradually and publish when ready. And we can see the acceptance criteria. Posts can be saved as drafts. Users can preview drafts before publishing, and draft posts show the last modified date because you want to know the last time that you updated them. So we can see this is all around the idea of having draft posts before you publish them. And then we have some bonus features. However, we're not going to be implementing any of the bonus features in this build. We are going to be focusing on the core requirements here. So with the requirements covered, let's now move on to modeling our domain. A fundamental step in any object-oriented programming project is to define the objects or domain that we'll be working with. The project brief has all of the information that we'll need in order to model our domain. So we're going to look at it again, but this time through the lens of domain modeling. We're then going to take what we learn and we're going to represent the domain we are to build in several diagrams. So let's start by looking at the project brief once more. So at this point in the domain modeling process, we're looking for nouns. We're looking for the things, the objects that we are to build. And it's pretty obvious what we have. Post, great example of an object. That's a noun, and our blog platform is going to be dealing with posts. We also know that a post belongs to a category, category being another noun, a great example of an object. Also, tag. A post can have many tags. Therefore, a tag is a great example of a noun, an object that we can use in our domain. If we look for this line up here, post can be drafts or publish articles. This gives us an idea of a state a post can be in, either a draft state or a published state. And considering a post can only be in one of those two states, that's a great example of an enumeration or an enum that we can use in our domain. In addition to that, we have this concept of a draft post, which is restricted to only certain people. Only certain people can view these draft posts, such as the person writing the post. Everyone else, the public, they're not to see these draft posts until they are published. Therefore, this tells us that we'll need to model the user. We'll need to have some authentication where a user logs in order to see drafts, but everyone who's not logged in, the general public, they won't see the drafts, but they will see the published articles. So user, that is another object that we'll need inside of our domain. In addition, there's plenty of information about our particular objects. So we know that a post has a title, some body text, tags, publication date. A category, well, that's almost certainly got some form of name, technology, travel, personal development. Same for a tag, Python, machine learning, book review, etc. Let's just do a high-level overview of some of these stories. Estimated reading time. Again, that could be another member of one of our domain objects. Category and tag counts. Again, that could be another member there. Draft management. We've already talked about the draft versus published status. And then we go on to our bonus features. So having looked through our project brief, I think we have enough information now to start designing our domain. So here we have a domain model. I've extracted the information from the brief and I've composed it in this domain model here. And it's there to show the objects that we're dealing with and the relationships between them. And we can also see some members of these objects. So if we just start in the middle here with post, we can see that a post has a title and it has some content. We saw that earlier. A reading time. And then we'll want to know the time and date the post was created and then last updated. Of course, a post needs some way of identifying it, so we have this ID here. And then we know a post belongs to a category. And I've given here category an ID, some way of identifying it, and then a name. The tag is modeled very similarly, so a post can have multiple tags. A tag at this point has an ID and a name. And then we have this post status. So a post can have a status, and the two statuses that we've identified are either draft or published. When a post is in draft, only certain people can see it, but when a post is published, it's available to the general public. And then, of course, we have this user up here. So the user that writes posts, or put another way, the post's author. So this user needs a unique identifier, which I've represented up here with ID. They also need some information that they can use to authenticate with our system. An email and a password is a fairly standard approach, so I've included those as well. This user I've determined also needs a name, and then we'll also store the date and time that user was created. I don't think it's necessarily important to store the updated date time right now, but it would be useful to know when that user was created. We can always add to that in future, of course. So this is our domain model. So having thought on this a little further, I then built it out into a class diagram. And that represents the classes that we are to implement in our system. And that looks like this. You have to forgive me that it's a little non-standard. I had to get a bit creative to fit it all on the slide, but here we are. So you can see it's very similar to the domain model diagram that we were just looking at. But of course, this has some additional information on there. We can see the types of the instance variables. Here, an ID I've decided should be a UUID, an email a string, password a string, so on and so forth. And I've also looked to elaborate on the relationship between our objects here. So a post can only have one user, represented by the number 1 here. But a user can write as many posts as they like, represented by this asterisk. A post can have one category, but a category can be linked to many posts. A post can have many tags, and a tag can belong to many posts. And then we know, of course, that a post has a status. It will either be draft or published. And you can see here that we've also represented those relationships as members, as instance variables, as we'll implement them. So we can see here post status is the type, and we've called that one status. We can see a set of tags here, and that is our relationship to tag. User author, that's our relationship back to the user here, the author of the post. And then we've got all of the other members that we're already familiar with. Title, content, created, updated, so on and so forth. So having analysed the project brief, I believe these classes would be a great place for us to start when implementing our project. But before we get to that point, let's now take a look at the user interface and see how it relates to this domain. Let's now take a look at the user interface for the blog platform that we are to build. So here's the current iteration of the blog platform. There are a myriad of different ways that this can be improved. However, it does meet the requirements and it will help us to develop our Spring Boot backend. So let's take a look through it. So on the home page here, we can see it's titled blog posts, and this contains our blog posts. The top one here, spaghetti, a love letter. We have one about woodpeckers and why boats are cool. So all dummy data, but it does show us a few things. We can see here the title of a post. We can see here the user that wrote the post. We can also see a snippet from the post. So we can see here we've got a date, and that's the date that the post was created. And then we've got a 2-minute read time, so how long the post will take to read. And then we have 2 little chips here. We've got one lifestyle and then the other one food. And we can see food has a little tag next to it. So this is how we represent the category, which in this case is lifestyle, and the tag, which in this case is food. But this post can have any number of different tags associated with it. If we scroll down to the next one, we can see again date, read time, travel tips, and very similar for the third post here. Now, if we take a look at the top here, we can see that we've got technology, travel, lifestyle, fish. These are our categories. By clicking on a category, we can see that we only see the blog post in that category. Again, very similar for the tags. If we only wanted to see posts with the food tag, if we clicked on that here, we can see spaghetti, a love letter, the one post with the food tag. Now, they can be used in combination. So we could say select lifestyle, and we can see here lifestyle food, lifestyle travel tips. If we then selected the tag travel tips, we only see one blog post. However, they're not fully fledged facets. The count doesn't update, but you could consider that a bonus feature if you did want to implement it. So let's now take a look at the blog page. So we can see here, we can either go back to the post page. Otherwise, we have the content of the blog post here. We can see the category, we can see the tag. So that's our blog post page. Let's now take a look at a blog post where we can see some formatting. So we can see here that we have some bullet points on this one. And we can see here we've got a title, so a H2 on this one. Now let's take a look at the categories and the tags pages. So we can see here we have the category lifestyle with a post count of 2, the category travel with a post count of 1. If we go to the tags page here, it's very similar. Travel tips, post count of 2, food, post count of 1. Now these views do change once you log in. So let's log in here. And then the password. And let's click on sign in. So now that we're signed in, we can take a look at the drafts and we can see we have a single draft post here, the same screen. However, because we're logged in, we can then edit. We can see we can change the title here. Maybe we want to make something bold, italics. Then if we scroll down, we can edit the metadata such as the category it belongs to. We can add some new tags. We can change its status from draft to published. And then if we click on update post, we can see that draft posts no longer contains any posts. However, we do have a new post here. It's all about coding. Then of course, if we wanted to add a new post, we can do so here. The screen is very similar. Of course, all of the fields are empty to begin with. And then if we chose to, we could also delete a post. Are you sure you want to delete this post? Yes, we are. And then the post is deleted. In addition to this, we're also able to delete the categories. So let's say we didn't want the category of fish any longer. We can delete that. And the same over on tags. We can delete, say, pasta here. Now you'll notice the delete button for travel tips and food. Well, that's grayed out, that's disabled because we can't delete a tag that has posts associated with it. And the same is true for categories. So you can see we can't delete travel or lifestyle. They are grayed out because they have a post count greater than 0. And of course, we can log out here and all of the extra functionality goes away. Now, it should be noted that we've implemented very, very basic authentication, but not authorization. So what that means is the user that logs in is able to see all of the drafts and they're able to update all of the posts. We haven't implemented authorization. That may look like a user only being able to edit their own posts. Authorization is outside of the scope of this build, but you can consider that a bonus feature if you did want to go ahead and implement that. So now that we're familiar with our user interface, let's now look at the architecture that we are to implement. So let's take a look at the architecture of the solution that we are to implement. The architecture for the solution is very straightforward. A user will interact with the React front-end application, and we saw that in the last lesson. The React front-end application will interact with the Spring Boot back-end application via a REST API. So that's to say the front-end will make calls to the back-end, and then the back-end will respond with the information that the front-end needs. The Spring Boot back-end application will save all of its information in a relational database, which we're going to use PostgreSQL. And we're going to run PostgreSQL in Docker to make things easy. Our Spring Boot backend is going to interact with the database using Spring Data JPA. So put another way, we're going to interact with the database with Java objects. We're not going to be writing SQL directly. And that's all the architecture that we're going to need. So next, let's take a look at the REST API that we are to build. Let's now take a look at the design of the REST API that we are to implement. Now it's worth noting that this is the REST API that our front end expects. So we'll need to implement it as it's seen here. However, there's nothing to stop you from implementing a different REST API design. However, you will need to provide your own front end for that build. So let's take a look at the REST API that our front end expects. So we can see here that the endpoints have a HTTP verb in this column here. And then we have the path. And then we have a description of what this endpoint does. And you can see that they are grouped up here. So we have one at the top, a second group, a third group, a fourth group. This first one here is about authentication. The next one is about managing posts, then categories, and then tags. So this first endpoint here is a post to API v1 auth login. Now on this particular build, we're using the prefix of /API/v1. This is optional and you don't need to use this prefix. However, a lot of production systems do, because it gives you the ability to introduce a v2, a v3, a v4, and in that way you can run multiple versions of a REST API side by side. So API v1 auth login. So to this endpoint, our user will post the email address and password, and if it's valid, they will receive a JWT. That JWT will then be provided on all calls that the front end makes to the back end. That's how the user will authenticate. So that first endpoint is authentication. Next, we have the post management endpoints. So we have get, posts, and that will get all of the published posts. We have posts, and that will create a new post. And then we have posts specifying the ID, that will get a specific post. Put, specifying the ID, that will update the existing post. Delete, specifying the ID, that will delete the post. And then we have this endpoint here, which is post drafts, and that will get a list of draft posts. And that's only available for authenticated users. So basic create, read, update, delete behavior for our posts. Perhaps the only nuance here is our list by default will return all the published posts. And this endpoint here, specifying drafts, that's only available for authenticated users, and that will return a list of draft posts. So next we have the endpoints for managing categories, get all the categories, create a category and delete a category. And it's almost identical down here, but for tags. Get all of the tags, create the tags, and delete the tag, specifying its ID. So now that we're familiar with the REST API design, let's look to create ourselves a new Spring Boot project. In this lesson, we'll create a new Spring Boot project by using the Spring Initializer. The Spring Initializer provides a web-based tool for generating Spring Boot projects with the necessary dependencies and configuration. To get started, navigate to start.spring.io in your web browser, and you should see a website that looks a bit like this. So now to select some configuration. We're going to select Maven as our build tool, so let's make sure that's selected there. And we're going to use Java as our programming language, so we'll select that also. For the Spring Boot version, we're going to choose 3.4.0, that being the latest general release version at the time of filming. By the time you see this, there may be a different version of Spring Boot available, so I'd recommend just going for the latest general release version. You can tell a general release version because it doesn't have the word snapshot after it, it won't have an M, it won't have an RC, it will just be a set of numbers, and you're looking for the highest numbers. So let's scroll down to our project metadata now. For the group, I'm going to choose Devtiro, and this just identifies the project. You could use a different group, it's not going to matter too much. For the artifact name, I'm just going to call this one blog, because we're creating a blog application. The name blog, that works too. For the description, I'll just say a blog application. The package name, Devtiro blog, works perfectly. And for packaging, I'm going to select jar, because that will bundle everything that we need into the jar file and make it easier to run. And I'm going to select Java version 21 as the latest long-term support release at the time of filming. Now if we scroll up here, we can select some dependencies. So let's click on the Add Dependencies button here. Now the first dependency we're going to need is Spring Web. We're going to be building a REST API, so let's use Spring Web to do that. We're also going to be interacting with the database using Java objects, so we're going to need JPA, so Spring Data JPA is our next dependency. We're going to be using a PostgreSQL database, so we're going to select the PostgreSQL driver as well. You can see that down there. To make development quicker, we're going to select Project Lombok, so we'll select that one too. I'll add it to the bottom of the list. We're going to be implementing some annotation-driven validation, so we're going to need the validation library as well. Again, that's put onto the bottom of the list there. And we're going to need the H2 database. We're going to be using PostgreSQL when we run our application properly, but we want the H2 database for our tests. So let's add that too, and that goes to the bottom of the list. Now, it should be mentioned that we are going to want some other dependencies a little bit later on. We're going to need Spring Security for one, because we're going to want to secure our application using JWTs. But rather than use the Spring Initializer for that, we'll simply add that dependency when we need it. With all of our configurations selected, let's now download this project and open it up in our IDE. In our previous lesson, we generated our blog application using the Spring Initializer. Now we'll understand the project structure and understand how the different components fit together. So let's head over to our IDE. So here we are in our IDE. This is the project freshly downloaded from the Spring Initializer. So let's start expanding some directories here. So if you're not familiar with this project structure, this is a typical Maven project structure. Source main Java containing our Java code. We can see here we've got the package that we declared in the Spring Initializer. In my case, Devtiro blog. And inside that package, we have the blog application class. We can see this class has a main method, so this is the entry point of our application. Further to that, we can see the @Spring Boot application annotation on top, marking this as a Spring Boot application. Other than that, we have our source, main, resources, and in there we have application.properties. This is where we'll place our properties to configure our application. At the moment, it only contains the application's name, which is blog. And then we have source test Java here. Exactly the same package, Devtiro blog, but we have a single test class, blog application tests. We can see this contains a single test here, just checking that the Spring context loads. And we can see that makes sense because on the top of this class, we have the @Spring Boot test annotation. And this will start up a test version of our application, so the Spring context is available inside of our tests. While we're here, let's just run this and see if it passes. Great, so the test passes absolutely fine. So let's minimize that. Now, if we scroll down to the root of the project, we have some files here. The ones I'll draw your attention to initially is mvmw and mvmw.cmd. These two scripts, combined with the .mvm directory up here, give us our bundled Maven instance. So we don't have to install Maven, we can simply use this instance that's bundled inside of our project. On Windows, we would call it using the mvmw command, and on macOS and Linux systems, we can use the mvmw shell script here. Of course, there's always the option if you're using IntelliJ that you can use the Maven integration, just like here. But let's minimize that for the moment. So let's now open our pom.xml file. This is our Maven configuration file, which contains all of the dependencies that we've included in our project. But that's not all. There is a lot in this file, so let's just go through it at a high level now. So we can see at the start, we have this node, the parent node. And this declares the artifact ID of Spring Boot Starter parent and the version of 3.4.0. You'll notice that matches the version of Spring Boot that we selected in the Spring Initializer. Well, that's exactly what this node does. So if a new version of Spring Boot does come out, you can change the version in here. We can see our group ID, com.devtiro in my case, and the artifact ID of blog. The version is 001 snapshot. That's fine, we won't really be versioning this project. And then we can see the name of the project and the description. So everything so far we selected inside of the Spring Initializer. So let's scroll down a little further. We can see the Java version that we selected in the Spring Initializer, version 21. And then we see some dependencies. Spring Boot Starter Data JPA. So we selected Spring Data JPA in the Spring Initializer, so that's why this one's included. Spring Boot Starter Validation. We selected Validation in the Spring Initializer, so that's why this one's included. We then have Spring Boot Starter Web included for the same reason. And then we have our H2 database. Now, while we're here, I'm going to change the scope from runtime to be test. We only plan to use the H2 database in our tests, so I'm just going to select that now to make sure it doesn't get involved in any of our production code. Next, we have PostgreSQL, Project Lombok, and our Spring Boot Starter test dependency. So that should be everything that we need for the moment in our project. So let's just load those Maven changes. So before we move on, let's just make sure that we're in a good state. So I'm going to go to the Maven integrations here. I'm going to go to Lifecycle. I'm going to clean and install this project. Let's click on play. Great, so that's a build success. Now, if you wanted to do that from the command line, you can simply use that Maven wrapper that we saw earlier. So this is a Windows machine. So I'm going to go mvmw, clean, install. There we go, that's a build success. The command will be ever so slightly different on a macOS and Linux machine, and you can find that command in the lesson notes. So now that we know our project's in a known good state, let's move on to running our database. In our previous lesson, we explored the structure of our Spring Boot blog application. Now we'll set up the PostgreSQL database using Docker Compose, which will serve as the persistent data store for our blog. So here we are back in our IDE, and what we'll need to do is if we just minimize everything here, and in the root of our project, I'm going to create a new file, and I'm going to call this one docker-compose.wml for YAML. Now this is the configuration file that's going to be used by Docker Compose. If you're unfamiliar with Docker Compose, it's a tool that defines and manages multi-container Docker environments. For our blog application, we'll need a PostgreSQL database server, and I'm going to include in there as well a database management interface. And we can do all of that via the YAML file here. So the content that we'll need will look like this. and I'll include this in the lesson notes. So we have two services running. We have DB, which is our PostgreSQL database here. We can see the Docker image Postgres latest. We're mapping ports 5432. So that means that the Postgres database will be available on our local host port 5432. If there's any issues, then we want our Docker container to restart. And we can see here a single environment variable, Postgres_password. This is how we specify the password for the Postgres user to our Docker container. In this case, we're using the password changeMeInProd ! Of course, it goes without saying, but you shouldn't use this approach in production. You should keep your secret secret. But as this is a development environment, we're just going to specify that password in there now. The second service that we're running here is Adminer, running the latest version of Adminer, again, always restarting, and we're going to make it available on port 8888. And it's via this interface that we can take a look at the database visually. Again, it's completely optional, but it is there if you do want to use it. You would log into Adminer using the same credentials as our application. So now that we have our Docker Compose file, let's open up a command prompt or a terminal, and let's run the following command. Docker-compose space up. Now you can see here I get an error. Now I do have Docker installed, but Docker currently isn't running. So if you do get an error that looks like this, the simple fix is just to start Docker on your machine, which I'm going to do right now. There we go, so that's Docker started up now. So I'm just going to run that same command once more. There we go, and we can see our Docker container has started up. So here's DB1, so Postgres, and we can see it's listening on port 5432. The database system is ready to accept connections. That's exactly what we want to see. If we scroll up a bit further here, we should see some console outs from Adminer. Yes, development server has started. So it looks like our environment is up and running. In our previous lesson, we set up a PostgreSQL database using Docker Compose. Now let's configure our Spring Boot application to connect to this database. So Spring Boot uses the application.properties file to manage database connection settings, and we can find that in source, main, resources, application.properties. And let's expand this. Now, in order to configure our application to connect to the database, we'll need some properties that look a bit like this. I'll include these in the lesson notes. So let's go through these properties now. So we have Spring Data Source URL. We can see that we're specifying the connection string for the database. So it's a JDBC URL. It's a PostgreSQL database that we're using, running on localhost, port 5432, and the database that we want to connect to is called Postgres, which is a database that's typically available by default on any running Postgres instance. We then specify the username and the password that we're going to use to connect to that database. The username is Postgres, and the password is exactly the same as the password that we specified in our docker-compose.yaml. This one right here. So next we have some JPA configuration. Here we're specifying DDL-auto as update. So once we start creating entities, Spring Data JPA will then automatically start creating everything that we need in the database, all of the tables, sequences, etc. We're setting show SQL to true, so we can see that printed out, and format SQL is a part of that. And here we're specifying the Hibernate dialect, which is PostgreSQL. When we include a PostgreSQL driver in our pom.xml file, Spring Boot usually works this out, but it doesn't hurt to be explicit. So with our properties specified, let's try starting up our application and connecting to the database. So let's open up our project here, go to Java, Devtiro blog, the blog application, and then let's click on the green triangle next to the main class. And we're going to run blog application.main. Okay, so we can see the application started up successfully. And if we scroll up here, we can see all of the information about our application connecting to the database. Add a connection to PostgreSQL, PG connection. Great, so it looks like our application is started up fine and it's connected to the database. In our previous lessons, we set up the database infrastructure for our blog platform. We'll now integrate Mapstruct, a code generator that simplifies the conversion between our domain entities and our DTOs. This mapping layer is crucial for maintaining a clean separation between our persistence and presentation layers while reducing some boilerplate code. We'll only be configuring Mapstruct in this lesson, we won't be using it. So we'll explore all of the details of using Mapstruct a little bit later in the course. So here we are back in our IDE. Let's take a look at our pom.xml file. Now you remember from earlier that we selected Lombok. We're going to be using that in order to create domain classes a lot faster than we would have without it. By using Lombok annotations, it's going to generate code for us. Now, we're also going to want to use Mapstruct to generate code. So to make sure that they work nicely together, we need to set up our project in a very particular way. And that starts up here in our properties. So in our properties, we're already specifying Java version 21. I'm going to add 2 more entries to that properties node. Here we're specifying the Mapstruct version of 1.6.3 and the Lombok version of 1.18.36. We're going to specify the Mapstruct dependencies in a moment, so it makes sense while we're including the Mapstruct version. But you might be wondering why we're specifying the Lombok version here, because Lombok was working perfectly fine without this. And the reason I'm including the Lombok version is that I'm making sure that the version of Mapstruct is compatible with that particular version of Lombok. So let's now use our properties. So if we scroll down here, we've got Lombok, so I'm just going to specify a version node on there. Using the $and annotation, I'm going to specify lombok.version. So that's going to use the version that we specified in the properties. And the next dependency we have is a test dependency. So I'm just going to create a new line and place in our Mapstruct dependency just before the test one, so everything is nice and organized. So we can see here org Mapstruct. Mapstruct is the artifact ID, and we're using the version that we specified in our properties. But it's not enough to specify the dependency. We're also going to have to configure the Maven compiler plugin. So let's scroll down a bit further, and we can see here the Maven compiler plugin. Now we can already see in here the annotation processor path for Lombok. I'm going to replace that with a more elaborate configuration here. So let's just expand this and go through it. So we're specifying the Lombok annotation process path just like before, specifying the version from up in the properties. We're also including Mapstruct in this configuration as well. We can see the Mapstruct processor, again using the same version that we specified in properties. And then we have a third entry, which is our Lombok Mapstruct bindings. And that version is 0.2.0. And these dependencies in this particular order will allow Mapstruct and Lombok to work together, at least in my experience of building this project. So let's just refresh Maven here, load our Maven changes. So that's all loaded. Let's open up Maven and let's again run clean and install. Great, that is a build success. It looks like our project is built fine and we're ready to use Lombok and Mapstruct. To run the front end, you'll need the front end code, and you can grab this from the Devtiro community site. There'll be details in the lesson notes. Once you have the code locally, you need to open up a terminal or a command prompt and navigate to the directory containing the front end code. That's exactly where I am at the moment. Once you're here, you need to install the necessary dependencies, and you can do that with the following command: npm install. There we go, so that's all the dependencies installed. All that's left for us to do now is to run our application, and we can do that with npm run dev. Great, so that's our application running, and it will be available on localhost port 5173. So here we are on localhost port 5173, and we have our front-end application. As we progress through the project and start to build out our backend, we should see the front end starting to look like what was presented earlier in the course. In our previous lessons, we've set up the foundational infrastructure for our blog application. Now we'll create the user entity, which will represent user accounts in our system. So here we are back in our IDE. So let's open up source here, main, Java, and then in Devtiro blog, I'm going to create a new package, and I'm going to call this one domain. And inside of the domain package here, I'm going to create a new sub-package and call this one entities. We'll also be creating our DTOs in our domain package. So we're going to use this sub-package in order to organize them. So inside of domain entities, I'm going to create a new Java class, and I'm going to call this one user. And let's expand this. Now, as we're creating a JPA entity, the first thing that I'll need to add to this is the entity annotation. And it would also be nice to specify the name of the table this is going to use in the database. So I'm going to use the @table annotation as well, specifying the name of users. I want this to use the table users in the database. In practice, this means that Hibernate is going to generate a table called users in the database, which this entity will map to. We're also using Lombok in this application, so let's add some annotations from Lombok. So we want a no argument constructor. That's something that JPA traditionally needs. We're also going to want an all arguments constructor, and we'll want getters generated for us, and we'll want some setters generated for us as well. And it's nice to use the builder pattern, so let's do builder too. Now you might wonder why I'm not using @data, and that has to do with our particular domain setup. Specifically, it's to do with the equals and the hash code that data generates when we use Mapstruct. So instead, we're going to have to use the getter and setter annotations separately. So let's start declaring some instance variables inside of our user entity, starting with our ID. So that's going to be a private UUID, and we'll call this one ID. Now the ID of a JPA entity needs to be annotated with the @ID annotation. And it would also be nice for the UUIDs to be generated for us. So I'm going to use the generated value with the strategy of generation type UUID. And that means if we try and save a user where the ID is null, JPA is going to generate a UUID for us and use that as the value. So that's the ID instance variable. So we know that a user is going to have an email. It's going to use an email and a password in order to log in. So let's specify that here with private string email. And on the top of this instance variable, I'm going to use the column annotation to specify some constraints. Nullable, false. We always want an email to be provided. Unique, true. We only want a single instance of each email in the database. We could also specify the name of the column in this annotation as well, but it would default to be the word email, and I'm pretty happy with that. It would default to be email because that's the name of our instance variable. The same for ID. Even though we've omitted the column annotation, inside of our users table in the database, this will be the ID column, this will be the email column. So a user is going to need to log in with a password. So we're going to say private string password. We'll put a column annotation on the top of this one, and we'll say nullable equals false. We always need a user to exist with a password. Next, we want the user's name, private string name. Again, we'll put a column annotation on the top here and add the constraint of nullable equals false. We always want a user to have a name. And the last thing on our user entity was the created date time. So we'll say private local date time. We'll call this one created at, and then we're going to put the column annotation on the top there and say nullable equals false. So with this, we have all of our instance variables specified, and we have the getters and setters generated for us with the annotations up here. We also have an all arguments constructor and a no arguments constructor as well. What we don't have is the equals and the hash code. And that's something that we need to generate. We need to write this one manually in order for Lombok and Mapstruct to work well together. This might not always be the case, but it certainly has been the case when I've been building this project. So if we right click here, we'll go to generate, and then we'll say equals and hash code. ID, email, password, name, and created at. Make sure they're all selected, and then we'll click on next and create. So that's our equals and our hash code implemented. So that will work for our JPA entity with both Lombok and Mapstruct in the mix. And now as a little bonus here, I'm going to specify a protected method, a void method, and I'm going to call this one on create. And I'm going to place the annotation on the top of this one, pre-persist. And this will say this dot created at equals local datetime dot now. And what this will do is every time a user entity is saved, where the created at instance variable is null, then rather than throw an exception, the local datetime dot now, that value will populate the created at instance variable. And this will all happen pre-persist. So before the user entity is saved into the database. This is completely optional, but does make things a little bit more streamlined. And with that, we have completed our user entity. In the last lesson, we created the user entity. Now we'll implement the category entity, which will provide a way to organize blog posts into broad groups. This categorization system will help readers find content they're interested in and enable better content organization for blog authors. So here we are back in our IDE. So let's open up source main Java, go to domain entities, and we'll create a new Java class. And this one we'll call category. And let's expand this. Again, as an entity, we'll need to put the entity annotation on the top of this class. And then just like before, we're going to say table, and the name is going to be categories. So the plural of category. And then we'll specify a no args constructor, an all args constructor, getter annotation, a setter annotation, and the builder annotation, all from Lombok. And now we can start declaring our instance variables. We're going to go with private UUID, ID. And just like before, we're going to say @ID, and we'll use the generated value annotation, specifying the strategy of generation type UUID. Now a category also has a name. So we'll say private string name, and we'll say column annotation on the top there, nullable equals false, and unique equals true. We don't want multiple categories with the same name, and this constraint will help prevent it. And that's the only things our category is going to need for the moment. So just like before, we're going to have to manually generate the equals and the hash code. So let's right click, go to generate, equals and hash code, next, making sure ID and name is selected, create, and there's our equals and hash code. And that's our initial implementation of category completed. In our previous lessons, we created the user and category entities to handle user management and content organization. Now we'll implement the tag entity, which provides a more flexible way to classify and organize blog posts. So here we are back in our IDE, and inside of domain entities, we're going to create a new Java class, and we're going to call this one tag. And let's expand this. So the tag is going to be almost identical to the category, at least for the initial implementation. So let's add the entity and the table annotations. We'll specify the name of the table to map to be tags. And then we'll specify the all arguments constructor, no arguments constructor, getter, setter, and we'll have the builder annotation as well. Just like before, we'll specify a private UUID, and we'll call that one ID, adding the annotations of @ID and the generated value with the strategy of UUID. So a tag has an ID and it also has a name. So we'll say private string name and add the column annotation to this. Nullable, false. We always want a name. Unique, true. We want our tag names to be unique. We don't want multiple tags with the same name in our database, and that will help prevent it. And just like with our previous entities, we're going to generate our equals and our hash code. Next, ID and name selected, and then we'll create. And that completes our initial implementation of our tag entity. So far, we've created entities for users, categories, and tags. Now let's implement the post entity and its associated post status enum, which together represent the actual blog content in our system. These classes will enable us to manage blog posts throughout their lifecycle from draft to publication. So let's create the post status enum. So inside of Devtiro blog domain, I'm going to put this one in domain rather than entities because I'm going to use this enum throughout the application. If I right click and then go new, Java class, and we'll call this one post status. And this will be an enum. Okay, so it's ended up in the entities package. So let's refactor and move this. And we'll move it to Devtiro blog domain refactor. Okay, so now it's in the right place. And to implement our post status enum, we're going to specify the two states that a post can be in, draft and published. And with that, we've completed our post status enum. So let's move on to the post entity. So inside of the entities package, I'm going to create a new Java class and call this one post. And let's expand this. So just like we've been doing so far, we'll put the entity annotation and we'll specify the table that this class maps to, which is going to be posts. And then we'll add our Lombok annotations, our noArgs constructor, allArgs constructor, getter, setter, and the builder. And now we can start specifying our instance variables. And we know the post has an ID, and this is a UUID. So we'll say private UUID ID. Again, adding the @ID annotation there. And we'll say generated value, where the strategy is UUID. We also know that a blog has a title. So we'll say private string title. And then in the column annotation on the top here, we'll say nullable equals false. We always want a post to have a title. We're going to allow posts to have the same title, as that's not unheard of. Now for the content. So we'll say private string content. And now in the column annotation for this, nullable equals false. We always want a blog post to have some content. And now we'll say column definition of text. And this will allow our column to handle varying content lengths. So as the content grows, the database can accommodate for it. Next, we're going to specify our post status. So we'll use our post status enum, and we'll call that instance variable status. And then we'll specify our column annotation, put that on a new line, and we'll say nullable equals false. We always want a post to have a post status. And in addition to that, we're going to use the enumerated annotation there, specifying the enum type of string. Typically, an enum would be represented as a number in the database. However, strings tend to be human readable and have some other benefits too. So we're going to use the enum type of string for this. Next, we'll specify a private integer of reading time, because we're going to calculate the reading time in minutes before we save the post. And that would be less resource intensive than having to do it every single time we display the post. So in the column annotation on this one, we're going to say nullable equals false. We always want a post to have a reading time. Next, we have our local date time for created at. So the date and time that the post was created. We'll put a column annotation on the top saying that nullable equals false. And then we'll specify our updated at. So local date time, updated at. And again, we'll say that the column nullable equals false. Now, just like we've been doing so far, we're going to generate the equals and the hash code. So we'll go generate equals and hash code. Next, making sure everything is selected. Next, create. So there's our equals and our hash code. And now let's use our pre-persist annotation again. So we'll say pre-persist, protected method, void, and we'll call this one on create. So on create, we want to set the created at to be local datetime dot now. Put the equals in there. And let's assign this to a variable, because we're also going to set the updated datetime to be now also. So when a post is created, both the created and the updated date time will be exactly the same date time, which is the date and time right now. In addition to this, we're also going to use the pre-update annotation. Protected void on update. And for this, we're just going to set the updated at equals local datetime dot now. So whereas this method will only be called when the entity is created, this one will only be called when the entity is updated. For the create, it would update the created at and updated at, whereas for the update, it will only update the updated at instance variable. And with that, we have completed our initial implementation of our post class. In previous lessons, we've created our user and post entities. Now let's configure the JPA relationship between them. So here we are back in our IDE, and let's start with our post entity, expanding this. Let's scroll up to our instance variables. So a blog post must always have an author, and this relationship needs to be enforced at the database level. So let's update our post entity to include the author relationship. And we're going to do that by adding a new instance variable here. Private, user, and we'll call this one author, because the user represents the author of the post. Now we're going to add some annotations to the top of this instance variable. And the first one is going to be the many-to-one annotation. And we're going to say the fetch type is lazy. And we're also going to specify the join column annotation here. And the name of the join column is going to be author_ID. And we're going to say nullable equals false. So the fetch type lazy configuration optimizes performance by loading post authors only when they're explicitly accessed. The join column annotation specifies that it's the column named author ID that is going to reference the author's ID, so the ID of the user to which this post relates. But we're not done yet. So we've done the post side of the configuration. Let's now move over to the user side of the configuration because we're setting up a bidirectional relationship here. So let's go to user. Now after name, I'm going to put a new instance variable in here. Private is going to be a list of post, and we'll call that one posts. And we're going to initialize that to be a new array list as well. And let's import list. We're initializing post to be a new array list because that helps prevent null pointer exceptions. And we're going to add an annotation to the post instance variable, and that's going to be one-to-many, which is the opposite to what we've put on the post. Note it's many-to-one here, and on user, it's going to be one-to-many. And inside of that annotation, we're going to specify mapped by to be author. And what that means is it's going to go to the post class and look for the author instance variable for the configuration that it needs. So let's now set up the cascades for this relationship. We're not going to specify any cascades on the post side since a post can't create or modify its author. So let's head over to the user class. Now inside of the one-to-many annotation here, we're going to specify the argument of cascade, and I'm going to specify cascade type all. And I'm also going to specify orphan removal, specifying that to be true. So what this combination means is when a user is deleted, all their posts will be automatically deleted. And this helps to maintain our database integrity. It would also be the case that if we added any new posts to our post collection here and then saved our user, those posts would also be saved. Although we may want to change this behavior later on, at this point in development, this sort of setup makes sense. So with that done, that's our initial setup of our user post relationship. So in our previous lesson, we set up the relationship between our users and their posts. In this lesson, we're going to set up the relationship between category and post. So each post must belong to exactly one category, and that establishes a mandatory one-to-many relationship, where a post always has one category and a category has many posts. So let's start over on the post class here, expanding this. So let's add a new instance variable, private, category, and we'll call this one category. And we'll add the annotation many-to-one on top. Again, fetch type of fetch type lazy. And we'll specify the join column with the name of category underscore ID. And we'll say nullable equals false. We always want a post to have a category. So a very similar setup between category and author there. So let's now go over to the category class. So let's add a new instance variable, private, and this is going to be our list of posts. And we'll call this one posts, and we'll say new array list. Again, helping to prevent that null pointer exception. And if we import list, and we'll put the one-to-many annotation on the top of posts, and we'll say mapped by category. Because on the post class, it's the instance variable of category that contains all of the information about this relationship. A note on cascades here. No cascades are needed as categories and posts have independent life cycles. So deleting a category should be prevented if it has posts. And we'll handle that in our service layer. And posts don't create or modify their categories. So we're not going to specify any cascade for this relationship. And with that, we've set up the initial relationship between our category and our post. In our previous lessons, we've established relationships between posts and both users and categories. Now we'll implement a many-to-many relationship between posts and tags, and this will enable flexible content classification. This relationship will allow for each post to have multiple tags and each tag to be associated with multiple posts. So back in our IDE, let's start with the post class, and let's expand this. And underneath category, we're going to place a new instance variable, a private set of tags. And we'll call this one tags, initializing it to a new hash set. We're using a set here instead of a list as it prevents duplicates and improves performance. And we're not really concerned with the order that tags are returned in. So to the top of our tags instance variable, we're going to place the annotation many-to-many, declaring a many-to-many relationship. And now we need to specify the join table that's going to be used for that many-to-many relationship. And now we'll specify the arguments to this annotation. And the first one is the name of the join table. And we'll call it post_tags. And this is what Hibernate will generate for us. And now we're going to specify the name of the join columns. So we'll say join columns, and then we'll specify the annotation of join column, where the name is the post ID. And that's one half of the relationship. And the other half is specified with the inverse join columns argument here. And we'll specify the join column where the name is tag ID. So in that join table, we'll store records where we map post IDs to tag IDs. And we've specified that here with this annotation. We've specified the post ID to identify the post and the tag ID to identify the tag. So that's the post side of the relationship configured. Let's now go over to the tag class. And we're going to add a new instance variable in here. And this will be a set of posts. We'll call that one posts, and we'll initialize it to be a new hash set. And to the top of this instance variable, we're going to place the annotation many-to-many. However, rather than specify all the information that we did before, we're just going to provide the mapped by argument, and we're going to specify tags. Because if we go to our post class and go to our tags instance variable, we can find all of the information about this relationship. A note on cascades. Tags and posts have independent life cycles. Deleting a post shouldn't delete its tags, and deleting a tag shouldn't delete its posts. This is why we're not going to specify cascade operations in our relationship mappings. So with that, we've set up the initial relationship between our tag and our post. In our previous lessons, we created our core domain entities, including the user entity. Now we'll create a repository interface that will handle data access operations for users. This repository will serve as the foundation for user authentication and management features that we'll build later. So here we are back in our IDE. Now the first thing that we need to do is create ourselves a repositories package. So in Devtiro blog, I'm going to create a new package, and I'm going to call this one repositories. And in the repositories package, I'm going to create a new Java class, and I'm going to call this one user repository. But it's not going to be a class, but an interface. And let's maximize this. So the first thing that we're going to do is put the @repository annotation on the top of our user repository interface here, marking it as a repository. Now we're going to extend JPA repository, specifying that the entity that this repository deals with is our user, and the ID type of the user is a UUID. We use JPA repository because it gives us all of that CRUD behavior, create, read, update, delete, and some pagination as well if we do need it later. So we're going to use JPA repository here. And with that, we have our initial user repository. We are going to be adding some additional methods to this later, but for the moment, this is all that we need. In our previous lesson, we created the user repository to handle user data access operations. Now we'll implement the category repository to manage the persistence of blog categories. So here we are back in our IDE. So just like before, inside of the repositories package here, I'm going to create a new Java class, and I'm going to call this one category repository. And it's going to be a Java interface. And let's expand this. And it's going to be almost identical to what we had before. So we're going to say extends JPA repository. This time, we're going to specify the type of category, because that's the entity that this particular repository deals with. And the ID type of category is UUID. And of course, we'll need that at repository annotation on the top of our class here. And with that, we've created our category repository. In our previous lessons, we created repositories for users and categories. Now we'll implement the tag repository to manage persistence of blog tags. This should be a familiar pattern by now. So inside of repositories, we'll create a new Java class, and we'll call this one Tag Repository, making it a Java interface. We'll extend the JPA repository, this time defining the tag entity and the UUID, which is going to be the ID type of the tag. And then we'll put the repository annotation on the top there, and that completes our tag repository. Again, we will be putting some additional methods on this later, but for the moment, this is all that we need. At this point, we've created repositories for users, categories, and tags. The last repository that we need to create is the Post repository. So let's do that now. So just like before, inside of the repositories package here, we're going to create a new Java class. This one's going to be called Post repository, and it's going to be an interface. We're going to extend JPA repository, defining the entity type as the post and the ID type as the UUID. And we'll put the repository annotation on top of the interface. And like that, we've completed our Post repository. Building upon the entities and repositories from previous lessons, we'll create our first API endpoint that lists blog categories. We'll implement this functionality layer by layer, starting with the controller and then working our way through to the service implementation. This endpoint will serve as a foundation for category management and content organization in our blog platform. So here we are back in our IDE. Now, the first thing that we need to do is create ourselves a new package here, and we'll call this one controllers. And this is where we'll store our controller classes. Now, inside of the controllers package, I'm going to create a new Java class, and I'm going to call this one category controller. And let's expand this. So we know our category controller is going to be a REST controller. So let's put the REST controller annotation on the top of the class. And we also know the base path this controller is going to represent. So we're going to go request mapping as the next annotation. And we're going to specify that path as /API v1 categories. And to make things easy, we're going to specify the required args constructor, which is going to create a constructor for us with any instance variable that we declare as final. Combined with Spring, this will of course inject those dependencies ready for us to use them. So let's define our first endpoint. This is going to use the HTTP GET verb. So we're going to go at get mapping, and it's going to use exactly the same base path that we specified at the top here. So we don't need to specify anything additional in that annotation. Now define our public method that's going to return a response entity, which will contain a list of, well, we can't return the category class because that is an entity. So we're going to need to return a category DTO, which of course doesn't exist yet. So we'll create one of those in a moment, and we'll call this method list categories. Now we're going to need to implement this in a moment, but before we do, let's create ourselves a category DTO class. So let's open the project up here and then expand domain. And then we're going to create a new package inside domain called DTOs. And inside DTOs, I'm going to create a new Java class, and I'm going to call this one category DTO. Now we're using Lombok in this project, so let's leverage some Lombok annotations. We're going to add the @data annotation here. Luckily, we can use @data on DTOs because they don't interact with Spring Data JPA, remembering that we couldn't use it on our entities for that very same reason. So data will generate most of the boilerplate code that we need for this class. I would like to use the builder pattern, so we'll put the builder annotation on there. And I'm going to specify a no-args constructor and an all-args constructor. And now we can start specifying some instance variables. Now, when we list out categories, I want to know about the ID. So let's say UUID ID. I want to know about the name of the category, which is going to be a string. And I also want to know the post count, which we'll use a long for that. And we'll call that one post count. So this is the DTO that we'll use when we list out our categories. So let's go back to the category controller here. And let's import the category DTO that we now have created. So now we can start implementing our list categories method. And we're going to need a category service next for our business logic. So let's head over to our project on the left here. And we're going to need to create a new package. So in Devtiro blog, I'm going to create a new package. And I'm going to call this one services. And inside of our services package, I'm going to create a new Java class. And I'm going to call this one category service. But it's not going to be a class, but an interface. So on this interface, I'm going to add a single method that we can call to list our categories. So we're going to say list category, remembering that we're going to return the category entity and not the category DTO, because this is a service in the service layer. And we'll call this one list categories. And there we go. And now we can create the implementation for this. So inside of our services package, I'm going to create a new sub package called impl. And we'll use this to organize our implementations. So inside impl, I'm going to create a new Java class, calling this one category service impl for implementation. Now let's say implements category service to declare that we implement the category service interface. And of course, this is going to give us a red squiggle. In fact, let's just expand this. This is going to give us a red squiggle because we haven't implemented that list categories method. So if we use implement methods here, click on OK, that will give us our method stub. Now, before we go any further, this is a service. So we're going to put the @service annotation on the top of the class here. That will make the class available for auto wiring and also inject any dependencies that we declare in this class constructor. However, like in our controller, I'm going to use the annotation of required args constructor. So we get that automatically generated constructor. And I'm going to declare a private final category repository. And that will be injected for us because this annotation here will generate a constructor with this as an argument because we've declared it as final. And this is the required args constructor annotation. So we now have the category repository available to use in this class. So to implement our method, we could just go return category repository dot find all and be done with it. That would return a list of categories. But if you remember on our category DTO here, we're specifying that we want to return the post count. So this is something that we're going to calculate along the way. So when we return our categories, we're also going to want to return that list of posts that relate to that category. So we can then work out the number of posts associated with that particular category. And find all would work. However, there is a way to optimize this. So if we go over to our category repository and we'll declare a new method in this repository, it's going to return a list of category and we'll call this one find all with post count. And let's import list. And we're going to place an annotation on the top of this method declaration. We're going to use @query in order to specify a HQL query to use. HQL standing for Hibernate Query Language. And we're going to say select. We'll use C for category. Select C from category, that being the name of the class. C, and we'll left join fetch C.posts. And by doing this, we sidestep the n+1 problem. So if we were to just use find all, then that would return a list of categories. And then Hibernate would go one by one for each category and then query to get the list of posts associated with that particular category. And that would lead to a great number of queries being sent to our database. However, if we use this approach, we only have to send a single query to the database, sidestepping the n+1 problem, and everything's a little bit more optimized. So now that we have our find all with post count, let's now use it in our service. So rather than find all, we're going to use find all with post count. So we've just implemented list categories in our category service. So if we go back to our category controller now, we'll first need to inject our category service into this class so we can use it. Just scroll down. Private final category service, and we'll call it category service. And then inside of this method, we'll call the category service dot list categories. And we now have a list of category, which we'll call categories. which we can now use. So let's import category. Let's put a semicolon here. But here's the challenge. We want to return a list of category DTO. We can't return our list of categories. So how do we fix this particular problem? Well, for this, we need a mapper. We need to convert from our category class into our category DTO class. And for that, we're going to use Mapstruct. So let's do that in our next lesson. In our previous lesson, we created the initial structure for listing categories, but we still need to convert our domain entities to DTOs. We'll implement a Mapstruct mapper in this lesson to handle this conversion efficiently and complete our category listing endpoint. This will enable us to properly format our category data for API responses while maintaining the clean separation between our domain and our presentation layers. So here we are back in our IDE. Now I'm going to create a new package to contain our mappers, calling this one mappers. And inside of that package, I'm going to create a new Java class, and I'm going to call this one category mapper, but it's going to be an interface and not a class. And let's expand this. Now, in order to declare this as a Mapstruct mapper, we're going to put the mapper annotation on the top here. Then we're going to specify the component model as Spring, this being a Spring application. And then we're going to say the unmapped target policy. And we're going to set this one to reporting policy.ignore. So when it can't map those properties to the target, we're just going to ask it to ignore them and not throw an exception or anything like that. Now, inside of our category mapper, we're going to specify a new method here. It's going to return a category DTO, and we'll call this one toDTO. And it's going to take as an argument the category, and we'll call that one category. And let's import category. There we go. Now, on the top of this particular method, we need to specify the mapping annotation. Not to be confused with mapper, this one is mapping. And we're going to specify the target of post count. So we're going to do something a little clever here. So we need to populate the value of post count in our DTO. So we're going to create a method inside of this interface to do that for us. So we'll say target post count, and the source is posts. And we'll say qualified by name, and we're going to say calculate post count. And this will be the name of the method that we are to create. So inside of our interface, we're going to say default. This is going to return a long, which of course is the post count. And we'll call this method calculate post count. And now we need to decide what the argument needs to be. So if we take a look at our category once more and scroll down here, we can see we have post, which is a list of posts. So let's copy this and then go back to our category mapper. And now we can implement this method. So we're going to say if null equals posts, then we're going to return 0. Because if post is null, then there isn't any posts. So the count of no posts would be 0. And now for the main implementation. So let's say post.stream. And I only want the post count to include posts that are published. So I'm going to filter where the post status dot published enum equals post dot get status. And then we'll simply call count, and we can return this. Let's just break this up onto some new lines. There we go. So if post is null, return 0. Otherwise, filter posts to only get posts that are published and then return the count. And the last thing that we need to do on this particular method is add the named annotation specifying the name that we've specified up here. There we go. So we now have a category mapper that we can use, remembering that Mapstruct is going to implement this interface for us. So we'll call our service, which returns a list of category, and then on each category, we'll call toDTO, which will then convert that into a category DTO, populating the post count by using this method here. So let's head back to our category controller now, and let's declare a second instance variable on this class, private final. We'll call this one category mapper. And now we can use the category mapper in our class. So let's change this to be a list of category DTO. And then we're going to call stream.map. Just break this up onto some new lines. And then for each category, we're going to call the category mapper dot toDTO on the category there. And then we're going to collect that to a list. And let's just optimize on that. There we go. So we now have a list of category DTOs. Of course, we still have a red squiggle here because we need to wrap it in a response entity. So let's say return response entity .ok to return a HTTP 200 with our categories. So that should be our list categories endpoint implemented. Let's just do a quick clean compile to make sure that everything compiles okay. Great, so that's a build success. So let's take this opportunity to start up our Docker Compose environment if it's not already. That's everything started. So let's now start our application. Great, so that's started up perfectly fine. So let's now head over to our browser and try this out. So here we are in our browser. And for this, we're just going to go to localhost 8080/API v1 categories. So here we are, we're hitting the backend directly via our browser. We take a look at the networks panel. When we call it, we can see that we're getting a HTTP 200 OK and the response of an empty array, which makes sense because we haven't yet created any categories. So with that lightweight test out the way, let's go back to our IDE. So here I have a terminal open and I'm in the front end code. So I'm going to run npm run dev. And now let's try it out via our front end. So here we are, and we can see we've got fail to load content, which makes sense because we haven't yet implemented our list post endpoint. However, if we go down to our networks panel here, we can see the call to categories comes back with an empty array and a HTTP 200. So it looks like our list categories endpoint is working as expected. Following on from our list categories endpoint from the previous lesson, we'll now implement the ability to create new categories through our API. And with this, we can truly test that our list categories endpoint is working. So here we are back in our IDE. So let's go over to controllers and go to our category controller, expanding this, and let's declare our new create category endpoint. So this one uses a post mapping, and it's going to use the same base path that we specified up here. So we don't need to specify anything in the arguments. And we're going to say public, and we'll say response entity of a category DTO. So the category that was created. And we'll call this one create category. Scroll down a bit. In the arguments for create category, we need to represent the category to create. Now we could use the category DTO type in that argument. However, I'd like to use a dedicated DTO, which will then allow us to use some validation annotations. So let's go open up our project on the left here. We'll go to domain. We'll go to DTOs, and then we'll create a new Java class. And we're going to call this one create category request. And let's expand this. So as a DTO, we can use the @data annotation on the top here. We'll also use @builder, and then we'll specify a no-ask constructor and an all-ask constructor. And now we can start specifying some instance variables. Now, in order to create a category, you simply need to specify the name, private string name. However, on the top of this instance variable, I'm now going to place several annotations, which is going to validate the value of name before the category is created. So the first annotation that I'm going to specify is the not blank annotation. Let's just import this. So that comes from Jakarta validation constraints. So name must be provided. It cannot be null and it cannot be an empty string. If it's either of those cases, then not blank is going to throw an exception. But there's more validation that I'd like to do. So I'm going to add a second annotation to the top here, and this one is going to be @size. So let's import this, again coming from Jakarta validation, and we're going to specify the name of the category must be between 2 and 50 characters in length. And here we can see a message which is returned in that exception if that criteria is not met. And now I'm going to add a third annotation to the top here, and this one is going to be @pattern. Let's import that as well. And this will ensure that the category name only contains letters, numbers, spaces, and hyphens. We don't want any special characters making their way into a category name. And with that, we have our create category request DTO that we can use. So let's head back to our category controller. And now we can use the create category request, and we'll call that one create category request, importing the create category request. Of course, this is going to be a request body. So we're going to put the request body annotation on that argument. But in order to make use of those validation annotations, I'm also going to add the @valid annotation as well to our create category request. So only if the value of our create category request object meets the annotations criteria, then will this method actually run. So we have a create category request, but we need a category in order to create a category. So we need to deal with this in our mappers, mapping from a create category request to a category. So let's head over to our mappers package here and open up the category mapper. Let's expand this. So I'm just going to add a new method to this interface. It's going to return a category and I'm going to call it toEntity, and it accepts a create category request. And that's all we need to do. Mapstruct can work out the rest. So let's head back to our category controller here and we'll call our mapper dot toEntity, passing in our create category request, and that will give us a category, which we're going to call category to create. So now we need to implement a new method on our category service in order to create a category. So let's go over to our category service here and let's add a new method declaration to this interface. It will return a category, the category that was created, and we'll call this one create category. And it will accept a category, which we'll call category, and that's the category to be created. So let's now go down to the implementation, hover over the red squiggle and implement methods, making sure that we implement create category. And now we can do the actual implementation. So before creating a category, I want to make sure that that category doesn't already exist. So I'm going to use a repository to do that, category repository, but I'm going to add a new method to our category repository. And this one's going to return a Boolean, and I'm going to call it exists by name, ignore case. And we'll pass in a string, which is going to be name. And Spring Data JPA can work out exactly what to do with this, because our category entity here has an instance variable of name, and we're passing in a string name here and returning a Boolean with the keyword exists. So we can now use this in our category service implementation. So we're going to say category repository dot exists by name, ignore case, passing in category dot get name. So we're going to say if a category with the same name already exists, we're going to throw a new illegal argument exception, and we'll say category already exists with name, and then we'll specify the name of the category, category.getName. And we might as well assign this to a variable while we're here. There we go. However, if it's a brand new category with a different name, we're going to return category repository.save, and then we'll pass in the category to be created, and that will implement our method. However, we'll also add the @transactional annotation on the top of this method because we are making multiple database calls, and we want them all to happen in the same transaction. So with our create category method implemented, let's head back to our category controller here, scroll down, and now we can call category service dot create category, passing in the category to create, and then that will give us our saved category. Okay, so we now have our saved category. We now need to return a response entity category DTO. So let's return a new response entity. And then the first argument will be the object that we want to return. So let's call category mapper dot to DTO, passing in our saved category. And the second argument is going to be the HTTP response code. So we're going to say HTTP status dot created. Okay, so that should be our create category endpoint implemented. So let's just do a quick clean compile to make sure everything compiles. Very good, so that's compiling fine. So let's restart our backend now. And now we can try out our new endpoint. Now, unfortunately, we can't try it out in the front end for this particular endpoint because we haven't yet implemented our login. And the UI only allows logged in users to create categories. However, we can do this via Postman for the same reason. We haven't yet implemented our authentication. So let's open up Postman. So here we are in Postman. So we've got the HTTP post verb used, and we can see the URL /API v1 categories. So we're going to select body in our request here, and then select raw, JSON, and now we can specify our request body. So it's going to be a JSON object with only a single property on here, which is going to be called name. And then we get to specify the name of our category, which for the sake of this, let's call test. We pull that up. So let's see if our endpoint creates a new category. Okay, so we have a HTTP 201 created returned here, and we can see a category with an ID, the name of test, and the post count of 0. Okay, very good. So let's head over to our front end. And here we are on the categories page. And now if we refresh this page, great, we can see a single category returned here, test, and the post count is 0. Great, okay, so we can see the request inside of our network panel, HTTP 200, and the array contains an object this time, which is our category name of test. So it looks like our create category endpoint is working as expected. In previous lessons, we've implemented various endpoints for managing categories. However, some of them have the potential to throw exceptions. So now we'll create a centralized error handling system to provide consistent, user-friendly error responses across our REST API. So here we are back in our IDE. Now inside of controllers, I'm going to create a new Java class here, and I'm going to call this one error controller. And let's expand this. Now to the top of this class, I'm going to add several annotations. The first one is going to be REST controller. The second one is going to be controller advice. And I'm going to add the Self4j annotation for logging as well. So it's in this class that we can handle the exceptions that are thrown throughout our application. So let's first implement the handler for the base exception class. So we're going to say public, and we'll just say response entity is the return type for the moment. We'll come back to that. And we'll say handle exception, and it's going to take the type of exception, which we'll call EX. And now we're going to add the annotation of exception handler to the top of this method, specifying exception.class. So this method will handle exception.class. Now I want this to return a standardized error format. So I'm going to create a new DTO for that. So inside of DTOs, I'm going to create a new Java class. I'm going to call this one API error response. And let's expand this. So as a DTO, we can use @data. We'll use the builder annotation, no R's constructor, all R's constructor. And now we can start specifying some instance variables. So we'll go private int status. And let's specify a message string as well. And then in case there's any more information, we'll specify a list of, let's create a nested class for this. So we'll say public static class field error, private string field, private string message. And then we'll say @data, @builder, no R's constructor, all R's constructor. And now we can use field error up here, and we'll call this one errors. Let's import list. There we go. So this API error response can be as elaborate as it needs to be, but it is standardized. So we can now use this over in our error controller, and that will be the type that we return from our response entity. So if we are catching a base exception, that means something's gone quite wrong. So let's do a log.error for this. And we'll just say course exception, and then we'll pass in the exception there. Now let's return our error response. So we'll say API error response, error, and then we'll say API error response builder. And the status, well, I think that's going to be HTTP status internal server error, using .value in order to get the int value from internal server error, which of course is a HTTP status object. And for the message for this one, we'll say an unexpected error occurred. We'll not specify any errors in there in that list because they're just not needed in this case. And now we can return a new response entity, passing in our error, and then we're going to use the HTTP status of internal server error. Great, so that will handle our base exception if one does bubble up to our controller there. Now we did throw an illegal argument exception as well. So let's declare a method to handle that. Public response entity, again, returning the API error response. And we'll call this one handle illegal argument exception. And then we'll pass in an argument of an illegal argument exception, which we'll call EX. And we'll put the exception handler annotation on the top here, specifying illegal argument exception.class as the exception to handle. So now we can construct our API error response. So we'll say .builder.build, assigning that to an API error response called error. So in the case that we get an illegal argument exception, I'm going to say that it's a bad request. It's like a HTTP 400 because the user has given us a request that we're not expecting or is invalid. So we're going to say status, HTTP status dot, and we'll use bad request dot value, and the message will be, so we could either put in a generic message here, or we could pass through the exception message. Now, there are some risks associated with doing that because you do expose some internal state. However, I am going to do exception.get message in this case because this is a development build, at least at this stage. Now, we can return a new response entity, passing in our error, and we'll say HTTP status dot bad request. There we go, and that will handle our illegal argument exception for us. And I believe that's all the exceptions that we're throwing at the moment. We'll add more to this as we throw different exceptions throughout the implementation of this project. Before we implement the last endpoint and our categories controller, let's make sure our tests are in a good place. So here we are back in our IDE. So I'm going to right click on our project and go run all tests. Great, it looks like everything is passing. However, if I were to open up a terminal here and then stop the Docker Compose environment that's running and then attempt to rerun all the tests, we can see that the test actually fails. And that's because it was relying on our PostgreSQL database. So before we go any further, let's fix this. So let's minimize this for the moment. Now, already in our pom.xml file here, have we included our H2 database? I believe it was somewhere up here. Yep, there it is with the test scope. Now, we just need to use this in our tests. And the way that we do that is to expand our test directory here, and we'll create a new directory within of that called resources. And inside of resources, we'll create a new file, and we'll call that one application.properties. And this is where we're going to put the configuration for our test to use our H2 database. So let's expand this. And this is the configuration that we're going to use. So here we're specifying the URL of our H2 database, the username, the password of the user to connect to said database, and then we specify the H2 driver. And then we have some JPA specific configuration here, specifying the H2 dialect, create and drop. So it will create all of the tables and all of the sequences, etc. in the database and then drop them at the end of the test, show the SQL, and then format the SQL. So with this in play now, if we were to rerun all of the tests in our project once more, we can see that the test passes absolutely fine. So let's implement the last category management endpoint. Let's implement the delete category endpoint. So here we are back in our IDE. So let's open up the category controller here. Let's expand this and let's go about implementing our delete category endpoint. So we'll say public response entity. This will be a void and we'll say delete category is the name of this one. Now let's add the delete mapping annotation to the top here. And then we'll specify a path because we want to know the ID of the category to delete, which we can then access as an argument down here by using the path variable annotation, specifying the type of UUID, and we'll call that one ID. Now we need to implement a method on our category service to delete a category. So let's go up to our category service here, and let's specify a new method which will return void, and we'll call this one delete category, and it will accept a UUID, which is the ID of the category to delete. Now, if we go down to the implementation class, and if we scroll over the red squiggle, implement the method, and we'll implement the delete category method there. So deleting a category isn't so straightforward, because we decided early on that we can only delete categories that don't have posts associated with them. So because of the setup of our entities, if we did try to delete a category that has posts associated with it, then we are going to get an exception. So let's check this now to ensure that we don't get that exception. So first we're going to need to get the category. So we'll say category repository dot find by ID, passing in the ID here. And what we'll do is we're going to assign this to a variable, optional category, and we'll just call this one category. Because this is a delete method, if you did try to delete a category that doesn't already exist, you could argue that the delete method has, by default, met its criteria. So I'm going to choose not to throw an exception in the case that the category is optional empty, doesn't exist. So we're going to say if category is present, and only then are we going to perform some business logic. So we'll say if category dot get, which is safe because we've checked it's present, dot get posts dot size is greater than 0. So that's to say the category has posts associated with it. Then we're going to throw a new illegal state exception. And we're going to say category has posts associated with it. In fact, let's just optimize this. There we go. So in the case that the category exists and it doesn't have posts associated with it, that's when we can delete it safely. So now we're going to say category repository dot delete by ID, passing in the ID. And that should be our delete category service method implemented. So if we now go up to our category controller here, we can use it inside of our delete category method. So we'll say category service dot delete category, passing in the ID from our path. And then we'll return a new response entity, and we'll use the HTTP status of no content. So that should be enough for our delete category endpoint, but we are throwing a new type of exception here. So let's add that to our error controller. Let's expand this. Now to save on some typing, I am just going to copy this here. For this method, we're not handling an illegal argument exception, but an illegal state exception. So we'll specify that as the argument type, and then we change the name to be illegal state exception. So the status code for this one, I'm going to go with conflict, remembering that's a HTTP 409, so it's still a client error. We'll still choose to pass through the exception message, but only because this is a development system at this moment. And then we will return that HTTP status conflict as the response entity code there. So with that implemented, let's try it out. So let's restart our backend here. Of course, we need to remember to restart Docker. Great, let's try again. Great, so now let's try out this new delete category endpoint. Again, we're going to have to use Postman for the moment because we haven't yet implemented authentication. So if we do a list categories call to the backend here, we can see we have that single category test, and this is the ID. So if we borrow that, and then we place that in the URL, and then we change from a get to a delete, and if we click on send, we get a HTTP 204 no content back. So if we now go back to the HTTP get, remove the ID from the URL, we can see we now get an empty list. So it looks like our delete category endpoint is working as expected. In our previous lessons, we implemented category management with error handling. Now we'll add Spring Security to our blog platform, ensuring that certain operations are protected while keeping our content publicly readable. So here we are back in our IDE. Now the first thing that we need to do is to include some additional dependencies. So let's head down to the pom.xml file here, and let's expand this. So if we scroll up a little bit, I want to find where the test dependencies start, which is here. And I'm going to place the following dependencies, and you'll find these in the lesson notes. So let's go through these. We have Spring Boot Starter Security, and this includes Spring Security. We then have several dependencies from JSON Web Token, JJWT API, JJWT Impl, and JJWT Jackson. And these are the dependencies that we'll need in order to use JWTs in our project. So let's just refresh our Maven changes to make sure everything is included. So with these dependencies included, we now have Spring Security and the ability to use JWTs in our project. Now, by default, Spring Security requires authentication for all endpoints, which we'll need to customize for our public-facing blog content. And to do that, we'll need to create a configuration class. So let's go up to project here. Let's scroll up. Let's create a new package, which we'll call config. And within config, we'll create a new Java class, and we'll call this one security config. And let's expand this. Now, the first thing that we'll need to do is to add the @configuration annotation on the top of this class, marking this as a configuration class. And now let's create our configuration. So for this, we're going to need a bean declaration, public, and it's going to be of type security filter chain. And we'll call this one security filter chain, passing in HTTP security, which we'll call HTTP. And we'll say throws exception. And now we can start customizing our security configuration. Now, in order to speed development along, I'm going to implement this and then we'll go through the implementation afterwards. So here we are. So let's go through this. We can see inside of this authorized HTTP request method here, we have a lambda. And on the first line, we are permitting all GET requests to this path here. So this is using the ANT matching convention. So basically any GET calls to our Post API, they'll be permitted. The same for categories, the same for tags. Anything else in this catch-all rule at the bottom here requires authentication. We're then disabling the CSRF tokens. We won't be using them for this project, but that's mitigated somewhat by the fact that we're using stateless authentication. Of course, there are ways of using CSRF tokens as well, but we'll choose to not use them for this project. Now, while we're here, we're going to create a few additional beans as well for Spring Security. The next one is going to be our password encoder. Bean, public, password encoder. We'll call this one password encoder, and we'll return password encoder factories dot create delegating password encoder. And we'll use this encoder for encoding our passwords. And this will default to using bcrypt. And this particular setup is going to need an additional bean down here, which will say public authentication manager, which we'll call authentication manager. And that's going to require authentication config. Say throws exception, scroll down a bit here, and we'll return config dot get authentication manager. And that's our initial Spring Security setup done. So let's try this out. So let's start or restart our blog application. Okay, that's our blog application started up fine. Now, to test out the Spring Security setup, I'm going to use Postman in this instance. So let's head over to Postman. So here we are in Postman. So let's try out listing our categories. So let's send this request here, get to API v1 categories, remembering that we allowed GET request on this particular path. Also note that we're not passing in any additional authentication information here. So let's click on send. Great, and we get HTTP 200, okay. And that's exactly what we're looking for because the list categories endpoint should be public. Now let's try creating a category. And this should require authentication. So let's change this to be a post. Let's go to our body here. Raw JSON, do a JSON object, name, and we'll call this one test auth. And we're expecting this to fail. So let's try this. Great, okay, we got a 403 forbidden. And that's clear evidence that we have Spring Security disallowing our request. So it looks like we've been able to include Spring Security and configure it. So in our next lesson, we'll move on to user management. In our previous lesson, we added Spring Security to protect our blog platform's endpoints. Now we'll implement user loading functionality to enable authentication based on our existing user entity. This implementation will bridge the gap between Spring Security's user management and our domain model. So here we are back in our IDE. Now I'm going to create a new package in Devtiro blog, and I'm going to call this one security. And this is where we'll include all of our Spring Security specific classes, outside of configuration, of course. So let's minimize some of these. And inside of the security package, I'm going to create a new class, and I'm going to call this one blog user details. And let's expand this. So the blog user details class is going to bridge the gap between our user entity in our domain and the user details interface that Spring Security expects. So blog user details is going to implement user details. And in doing so, we'll need to implement several methods. So by hovering over here, we can click on implement methods and we'll select all of them and then go OK. So these are the methods that we are to implement: get authorities, get password, get username, is account non-expired, is account non-locked, is credentials not expired, and is enabled. So in order to bridge the gap between our user and user details, we're going to need our user. So let's create a private final user. That's going to come from our domain entities. Call this one user. And we'll put the @getter annotation on the top of this class to create a getter for us. And then we'll need to create a constructor for this. And we can do that with required as constructor. So when creating a new blog user details, you simply pass in our user entity. So now that we have our user entity, we can get to implementing these methods. Now for authorities, we're not actually implementing any authorization for our blog platform, at least not in this iteration. So we're going to return a list of new simple granted authority with the role of user. This basically means that every single user is going to have the same access, the standard user role, and whatever that gets you access to. For get password, we're going to return user.getPassword, get username, user.get email, because we're using the email address as the username. Now for these methods, we're not going to implement the concept of expiring accounts or expiring credentials, at least not in this iteration. So we're simply going to return true. And we get this yellow underline because it's essentially the same implementation as the superclass, but that's okay for our implementation. So is account non-locked? True. Is credentials non-expired? True. And then is user enabled? True. And essentially what this means is if the user has valid credentials, they're able to log in. But this does give us the extensibility in future that we can implement these features here and thereby prevent a user logging in if, say, their credentials had expired or if their account was locked. So that's our blog user details implemented. So we're bridging the gap between our domain user and our user details. Now we are using email address as the username here. So it would be useful for us to be able to look up users using their email address. So we can do that by going over to project here. And let's just check on our user repository and let's expand this. So let's put a new method on our user repository to be able to look up our user using the email address. So this will return an optional user and we'll call this one find by email, passing in the string of email. Because we're using this naming convention, we don't need to implement the method or provide a query. Spring Data JPA can work it out for us. So we're now able to look up a user by their email address, which is great because the next step for us to do is to implement the user details service. So let's open up our project here. And then inside of security, we'll create a new Java class and we'll call this one blog user details service. And let's expand this. So the user details service is used by Spring Security to look up users. In our case, this is from the database. So if we were to say implement user details service, we get a red squiggle because we need to implement a single method. Implement methods, okay. We need to implement this load by username method. Takes a string, which is the username, and then returns the user. But of course, we're not using username, we are using email. But as a string representation, this will work perfectly fine. So in order to implement this, we're going to need our user repository, private final user repository, and then we'll place the required R's constructor on the top here, which will create a constructor for us, passing in the user repository. And now we can use the user repository in our implementation of this method. So we'll say user repository dot find by email, the method we just created on our repository, passing in the email argument to the load by username method here, and that will return an optional. So, or else throw. If the user is not found, we're going to throw, in this case, we don't need the throw keyword, a new username not found exception. This exception is required by Spring Security in this case. So we'll say new username not found exception, user not found with email, and then we'll just say the email address there. So let's assign this to a variable of type user, call it user. We need to import our user from our domain. Now this method requires user details, so we need to return a user details object. So in this case, we can return a new blog user details, the class we just implemented, passing in our user. And like that, we've implemented our load by username method. So before we look to use our blog user details service, we need to handle some errors. Now, this particular method is going to throw a username not found exception. Inside of Spring Security, that's going to then rethrow something called a bad credentials exception. So we need to handle that bad credentials exception. So let's head over to our project here. Let's go to our error controller. Let's expand this. And I'm just going to add a block to handle that bad credentials exception because it's going to be very similar to what we've got before. So here we have our method to handle our bad credentials exception. We can see here the bad credentials exception. If we hover over with control held, we can see it comes to us from the org Spring Framework security package. And then we are returning our standardized error response with the status of unauthorized, with the message incorrect username or password, and then our response entity, again, with unauthorized here. And with that, we've implemented the service that we need to load users. So in our next lesson, we'll build on this even further. Building on our user loading functionality from the previous lesson, we'll now implement the authentication endpoint that clients will use to obtain JWTs. This endpoint will validate user credentials, return that JWT, which can then be provided by the client in subsequent requests. And this will form the foundation to enable secure access to our protected resources on our blog platform. So here we are back in our IDE. Now, the authentication process requires dedicated DTOs to handle the login request and responses. So inside of our DTOs package here, we'll create a new class, and this class will be called login request, and it will represent the login request. And let's expand this. Now, as a DTO, we can make full use of Lombok here. So we'll go at data, all R's constructor, no R's constructor, and we'll use that builder as well. And this DTO has two fields, the private string email and the private string password. So in order to log in, the user will provide their email here and their password. And that's the request. So let's now create the response DTO. So inside of the same package, we'll create a new Java class and we'll call this one auth response. Let's expand that. Again, let's put our Lombok annotations on the top here. Data, all R's constructor, no R's constructor, and our builder. And in the auth response, we're of course going to need that token, which will return as a string. So that will be our JWT value. And we're also going to return private long expires in. So the client knows when the token expires. This information is baked into the token itself, but it's always useful to have that information available easily. So now that we have our request and response DTOs, let's go ahead and actually implement the logic to do this authentication. So let's open up our project here. Let's expand our services package. And in our services package, we're going to create a new Java class here. And we're going to call this one authentication service. And it's going to be an interface rather than a class. So let's expand this. So at this moment, the authentication service is going to have two methods. One is going to return user details, and we'll call this one authenticate. And we'll pass in the email, and we'll pass in the password. So this will authenticate the user. And then we're also going to have a second method on there, which will return a string that we'll call generate token. And this one will take user details like so. So you pass in the email and the password in the authenticate method here, and we get user details returned in the event that the email and the password are valid and match an existing user. And then we have the generate token, whereby you can pass in a valid set of user credentials, and that will generate a token value, which is returned as a string. Now, we could get right to implementing these methods, but I feel it's more useful to see how this service can be used in the controller layer, so in the presentation layer. So let's move on to our controller next and then circle back to implement these methods. So let's open up our project here. Let's scroll up to our controllers package, and we're going to create our new Java class, auth controller. And let's expand this. Now this is going to be a REST controller. For the request mapping, we're going to specify the path of /API v1. That's the prefix that we're using everywhere else. And then we'll use auth. And we're going to specify a required R's constructor on here as well. Now our auth controller, of course, is going to use our authentication service. So we'll say private final authentication service, like so. And now we have access to our authentication service in this controller. So let's define a method that does the actual login. So this one will say public, and it will return a response entity of the DTO that we just created, auth response. Call this one login, and it's going to need a request body of the DTO that we just created, also login request. And this one is going to be a post mapping. Scroll down a bit. So the first thing that we're going to do is call our authentication service. We'll call authenticate, passing in the email and the password, which we can get from our login request. Get email, get password. And let's just put these on some new lines. There we go. We'll assign that to be on a variable user details. Remembering if the email and the password aren't valid, then it's going to throw an exception and be handled by our exception handler. So in the case that it's valid, we have some user details. So what we'll now do is call our authentication service here, .generate token, passing in the valid set of user details. We'll assign that to a string, which we'll call token value. And now we can go about creating our response DTO. So we'll say auth response .builder, and then we'll pass in the token value, expires in, and I think we'll just default to be 24 hours everywhere. So 86400 in seconds, and then we'll build this. Of course, you can be more specific with your expiry times, and obviously that's something to bear in mind when implementing a system for production. But for the sake of this exercise, we're just going to say that tokens expire within 24 hours. So we now have our auth response. So let's assign that to a variable called auth response. And now we can return our response entity .ok of our auth response. There we go. So this endpoint is a post endpoint. It receives a login request in the request body. We extract the email and password, then use our authentication service to authenticate that user. So in the case that the email and password are valid, we get user details. In the case they're not valid, an exception is thrown and handled by our exception handler. So now that we have these user details, we're able to generate a token from them. And this is our JWT token value. We then construct our auth response DTO and return that wrapped in a response entity. And we're using a response entity here for consistency everywhere else. So now that we have our controller, we can now move on to implementing our authentication service. In our previous lesson, we set up the authentication controller and service interface for our blog platform. In this lesson, we'll implement the authentication service. So here we are back in our IDE. So let's scroll down here to our services, go to our import package, and then we'll create a new class in here, and we'll call this one authentication service import. Let's expand this. Now the authentication service import is going to implement the authentication service. And then we get the red squiggle because we haven't implemented our methods. So let's go implement methods, okay. And then we get our method stubs. So before we go any further, let's put the @service annotation on the top of this class. And we're also going to put the required R's constructor on there as well. Now the authentication service import class has a few collaborators. So we'll say private, final. It's going to need the authentication manager. It's going to need the user detail service. And it's also going to need a few bits of key information. We'll say private string, and we'll call this one a secret key. And we'll load this secret key from our configuration. So we'll do that with @value, not the one from Lombok, but the one from Spring. And then we'll say the property name will be JWT.secret. Now we could do this with configuration properties, but this is a simple way of doing it also. And we're also going to need private long, and we'll call this one JWT expiry, and we'll do this in milliseconds here. And as we've hard-coded this to be 24 hours elsewhere, let's also do the same in milliseconds here. There we go, and we can make this final. Okay, so we can of course make this configurable throughout the application, but for the sake of this exercise, we'll just hard-code to 24 hours. So now we have everything we need to implement our two methods. So let's start with the authenticate method. Now for this, we can delegate to the authentication manager, which will then of course delegate to the authentication provider. So we'll say authentication manager dot authenticate, and that will need an authentication token. So we'll create a new username password authentication token. Let's put that on a new line there. And then we can pass in the email, which is the username that we're using, and the password. Okay, so in the case that the authentication was successful, then we can move on. In the case that the authentication was unsuccessful, it will throw an exception. So at this point, the authentication was successful. So we're going to call the user details service dot load by username, and then we'll pass in the email address. And we'll assign that to a variable, user details, which we'll call user details. There we go. And then we can return those user details. So really the implementation for our authenticate method is just passing through to the authentication manager. So now for the generate token method. Now the generate token method is a little bit more involved. And for this, we're going to be using the JWT library. So tokens contain claims. So that's the first thing that we'll need to create. So string object, we'll call this one claims, and then we'll create a new hash map. Let's import map. Now we can fill this with any claims our application needs. At the moment, it doesn't need any. So now we're going to use JWTs.builder. This is the library that we imported, and it's going to allow us to create a JWT. So we can set our claims. Now we'll set the subject, and that's going to be our user details dot get username. We're going to set issued at, and that's going to be a new date. And we'll say system dot current time in millis, set the expiration. So that's going to be a new date, system time in millis. And to that, we're going to add the value of the variable JWT expiry milliseconds. That, of course, representing 24 hours. Let's place that inside of the date constructor. And now we need to sign the JWT using our secret. And for that, probably the easiest way is to create a private method. So let's do that. So we'll say private, and that's going to return a key. And we'll say get signing key. Now the first thing that we need to do is take our secret key. We'll get the bytes for that. And let's store that in a variable, which is going to be a byte array. We'll call that one key bytes. Now we can return, we'll say keys dot, and we'll use hmax char key for our key bytes. There we go. And that should give us what we need in order to sign our JWT with our secret. The documentation for this is usually rather good. So there's tons more information in the official library documentation. So now that we've signed, we'll now call compact. That will give us a string. And rather than return an empty string here, we'll return the result of this builder. However, let's also specify in sign with the signature algorithm, which is HS256. There we go. And that should complete our generate token method. So the last thing we should do before we forget is open up our project here. We'll go to our resources directory, application.properties, and then I'm going to add a new property in here, which is going to be jwt.secret. And then it needs to be a secret, which is going to be at least 32 bytes long. Anything less than that, and the library is going to throw an exception. But with that, we've got the initial implementation of our authentication service. In this lesson, we build on our authentication implementation from previous lessons. We'll now create a filter to validate JWTs on our protected endpoints. This filter enables stateless authentication by validating tokens and establishing the user context for each request. So here we are back in our IDE. Now let's go over to our authentication service and let's expand this. So at the moment, we're able to authenticate a user. We're able to generate a token. Let's add an additional method to this service. It will return user details, and we'll call this one validate token. And it will take a string token, which will be the value of our JWT. So authenticate takes the email and password, authenticates the user, returns their user details. Generate token will turn the user details into a JWT, and this one will turn the JWT into user details. So let's go down to the authentication service, hover over, go to implement methods, implement, and now we have the validate token method stub to implement. So our first challenge is to extract the username from the token. So to do that, I'm going to create a new private method. Private, it will return a string, which will be the username, and we'll call this one extract username. And it will take the token string as an argument. And we're going to say JWTs dot parser builder. We'll set the signing key. And again, we'll call the get signing key method that we've created down here. We'll call build. And then we can call pass claims, passing in our token. And then we'll call get body. And that will return a claims object, which will assign to a variable called claims. Let's import claims. Okay. And now we can call claims.get subject and return this. And that will return the username, remembering that we put the username into the subject up here. Now, it should be noted that an exception will be thrown if the, for example, signing key doesn't match. So we only return a username if it is a valid JWT. So we can now use our extract username up here in our validate token method. So we'll say string username equals extract username, passing in the token. And then we'll go return user details service dot load user by username, passing in the username. Of course, we could also process some additional claims at this point. However, we're not using any additional claims in this implementation, at least not in this iteration. So in this way, we're able to pass the token, relying on the JWTs object here to do all of the heavy lifting. So all of the complexity is dealt with in this builder pattern here. And then we extract the subject, which is the username, and we only get that if it is a valid JWT. And then we're able to use our user detail service to load the user by username, passing in the username. And that should do it for our validate token method. So now that we have this method, we can use it in a custom filter. So let's go up to project here. Let's go to our security package and let's create a new class. And we'll call this one JWT Authentication Filter. And let's expand this. Now this class is going to extend the once per request filter, because of course we only want this to run once per request. So we hover over this, go to implement methods, go OK, and let's put these on some new lines. We now have this do filter internal method to implement. So to implement this method, we're going to need the authentication service. So let's put the required R's constructor on the top here. And now we'll say private final authentication service. And we'll call this one authentication service. And now it's available to use in our class. So inside of the do filter internal method, the first thing that we'll want to do is to extract the token. So we have that to pass in to our authentication service. And for that, I think we'll do a private method. So private string, and we'll call this one extract token. That will take the HTTP servlet request, which we'll call request. And the first thing that we'll do is try and extract the authorization header. So request.getHeader and its authorization. And we'll assign that to a string, which we'll call bearer token. Remembering that a JWT will be provided in the request prefixed with the word bearer. So we'll now need to split that out so we only have the token value. So we'll say if bearer token does not equal null, we'll say bearer token dot starts with bearer space. So if the bearer token is not null and starts with the word bearer, then we're going to return the bearer token dot. We'll use substring for this, starting at index 7. Of course, you can make this implementation as refined as you like. This is a very simple implementation, but should do what we need it to at the moment. Now, if we find that the bearer token is null or doesn't start with the word bearer, then we're going to simply return null in this case. So we can now use this extract token method up here. So we'll say string, and we'll call this one token, extract token, passing in the request. So we'll now say if the token does not equal null, then we can look to validate the token. So we'll say user details, and to this variable, we'll go authentication service dot validate token, passing in the token that we've just extracted. And providing it was a valid JWT and the credentials are valid, then we can go about creating a new username, password, authentication token. So this is our authentication object. And to that, we'll need to pass in our user details. For credentials, we'll just pass in null. And for authorities, so user details, get authorities. We'll assign this to a variable called username password authentication token. And we'll call this one authentication. as it represents our authentication object. And now we can go about setting this on our security context. So let's do security context holder dot get context dot set authentication, and then we can set the authentication object on the security context. And that makes that authentication object available for the rest of the request, essentially setting the authenticated user. Now, something which can be handy later on is we'll set the user ID. Rather than having to look up the user by the email address each time, we can simply just use the user ID. So if we say if user details, instance of, and I like to use this sparingly, but I think this is a good case for it, instance of log user details, then we'll say request dot set attribute, and we'll call this attribute user ID. We'll cast our user details to blog user details, and then we'll call on that get ID, which doesn't yet exist on blog user details. So let's create the method in blog user details, remembering our ID is a UUID, and we can return user dot get ID. If we go back to our JWT authentication filter, we now have our user ID, UUID type, set as an attribute user ID, which we can access throughout the request. So at the moment, exceptions are going to bubble up. And that means we are going to get exceptions returned if there is, say, an invalid JWT. Because we're in a filter here, we simply choose to not authenticate the user rather than return an exception each time. And then we can rely on the rest of the application to do what it needs to do when there is no authenticated user. So what we'll do then is we're going to wrap all of this in a try, and we'll say catch exception EX, and we're simply going to say in a comment, do not throw exceptions, just don't authenticate the user. And it's good practice to put a log line in rather than just duck an exception like this. So we're going to add the self4j annotation to the top here, which makes the log variable available. And we'll put a warn message in here, which says received invalid auth token. And at least we're aware when there's invalid auth tokens being passed into the system. And then the last thing that we need to do on our filter is call filter chain dot do filter request response. So that's the first iteration of our JWT authentication filter done. Now let's look to use it. Now that we've implemented our JWT authentication filter, in this lesson, we'll look to use that filter and log in with a user. So let's open up our project here, go over to our config, security config, and let's expand this. And let's scroll down. So the first thing that we should do is inside of our request matches, let's add another line. And now that we have new endpoints to do authentication, let's put in auth in here. And we'll say any post request to v1 auth is permitted because we're using this endpoint in order to log in. And with that done, we can now configure our filter. So let's create a bean for our filter. So we'll go at bean, public, JWT authentication filter. We'll call that method JWT authentication filter also. And then we'll return a new JWT authentication filter. And as for the arguments, it requires the authentication service. So we'll pass that in as an argument up here, authentication service, like so. And we now have our JWT authentication filter bean available. We'll add a second argument to this method, which is going to be our JWT authentication filter. And Spring will know to inject that because we've declared the bean just up above. And now on the last method here, we can call dot add filter before JWT authentication filter, and we'll add this before the username password authentication filter dot class. And with that, we should have everything that we need in order to have some working authentication in our system. Now, quick disclaimer, it should be mentioned, this is a very basic implementation and you'll want to do a whole lot more in a proper production system. However, this should give us the bare minimum. So if we click on refresh up here to start or restart our application, We can see that we're missing a bean of user detail service in our configuration here. So let's pull that down and we'll declare a new bean. Say public user detail service, and we'll return a new blog user detail service, which requires the user repository. So we'll say user repository, and then we'll pass that in like so. And that makes the user detail service bean available for our application. So let's try once more. And that's our application started up successfully. So let's try this out. Let's start with Postman and then work our way over to the front end. So here we are back in Postman. Now at the moment, we don't have any users in our application. So let's see what happens when we try and authenticate when the user's credentials aren't valid, purely because the user doesn't exist. So here we have the email for user@test.com. Again, just a dummy value. And the password we've set here to be password123! Again, not a strong password, but we're just testing. So we're going to send this to API v1 auth on a post. Okay, so we get a 401 unauthorized. So we can see here, incorrect username or password. Perfect, exactly what we expect. So next, we'll create a user and then log in with that user. Now, there are various different ways that we can create users in our system. Of course, we can build out a full user management part of our application. But in order to keep things simple, we're going to simply create a user when we start up our application, and that will be the user that we use for our blog. Of course, feel free to build this out as far as you would like. But for the moment, we're going to go to security config here. Let's expand this. And here we have our user detail service bean declaration. So rather than just return our blog user detail service, I'm going to assign that to a variable, blog user detail service. There we go. And we can return that at the end here. And now we can look to create the user if they don't exist. Again, this isn't something you want to do in a production system. You want to build out that full user management functionality. But for us, it should work perfectly fine for the moment. So we're going to use the user repository that's been passed in as an argument up here. And we're going to say find by email. And we're going to use the same email of the user that we've just tried out in Postman. And that was, let's assign that to a variable, string email. And that was user@test.com. Again, just a dummy value. And let's pass it into find by email. Now this will return an optional. So we only want to create the user if they don't already exist. So we'll then say or else get, and then we'll go about creating our user. So we'll say user, making sure we import from our domain .builder.build. Assign this to a variable which is called new user. So we'll not set an ID, we'll not set any posts. Let's set a name. We'll say test user, set an email, which is going to be that email address there. We'll need to set a password, of course. And for that, we'll need to use our password encoder.encode. And we'll just have the string password as the password. And we just remind ourselves what's on user. We're setting the email, setting the password, we've set the name. Post will default to a new array list. Created that will be populated for us. So that's all we'll need to do. So what we'll do then is say user repository dot save, and we'll save our new user, returning that at the end of the Lambda. And in this way, we're just going to create a test user that we can use if that user doesn't already exist in the database. So let's try restarting our application here. Okay, it looks like our application is started up fine. So let's head back over to Postman. Let's just send this same request that we sent a moment ago and see if we are able to log in. We're getting a HTTP 401, but that's because I set the password as password, not password123. So let's try once more. Wonderful stuff. So we now get a HTTP 200 and we get a token value here, and we've got an expires in value as well. So it looks like our authentication endpoint is working as expected. So let's now try this out in our front end. So here we are in our front end. So let's head over to the login page here. Let's just pull this down a little bit. And let's try logging in. So user@test.com. And the password for this one was password. And if we click on sign in, we get a HTTP 500, which is unexpected. So let's take a look at this and see why. Post 500, let's take a look at the response. An unexpected error occurred. Okay, our front end is displaying the error because it's in the standardized format, but it seems like we are getting a 500. That's not a lot to go on. So if we take a look at this request, we can see that the payload is sending the email and the password correctly. That's all correctly formed. We are using HTTP post, but it appears I've made a mistake on the URL here. So the front end, as we initially designed, is using v1 auth login. Whereas if we go back to our IDE, we've implemented API v1 auth. So it should be /login. And because we've changed the URL here, we'll need to go over to our security config. Let's just minimize that actually. Maximize that. And we'll scroll to our security filter chain and change that also to be login, allowing calls to the login endpoint. So if we restart our backend now, okay, so that's our backend restarted. Let's head back to our front end. And if we try logging in once more, fantastic. So it looks like the login was a success. Let's just track down that call. Login 200. Great. So here's our login, HTTP 200, v1 auth login, and here's our email and here's our password. So it looks like we have now successfully logged in, which means we get access to the drafts post page. We can create a new post. We can do everything a logged in user can do. Now, if we go ahead and log out for a moment, let's just bring the networks panel back actually. Just before we move on, let's just make sure that we can't log in with just any username and password. So let's go user@test.com because we know that to be a valid user. And let's just put some random characters in the password. And now let's try signing in. Okay, great. So we get a 401 on the response there. Great. So it looks like our authentication implementation is now working as expected. In our previous lessons, we implemented user authentication and security for our blog platform. In this lesson, we'll create an endpoint to list all of the tags and their associated post counts. So here we are back in our IDE. Now we're going to use a dedicated DTO for our tag data. So inside of domain, DTOs, we're going to create a new Java class, and this one's going to be called Tag Response. Let's expand this. Now, as a DTO, we can make full use of Lombok. So at data, all args constructor, no args constructor, and we'll put builder on there as well. Now we can add our instance variables. So the things we want to know about our tag. So the first one is going to be the ID, which is a UUID type, and we'll call that instance variable ID. I also want to know the name of the type. So we'll do an instance variable string type name. And I also want to know the post count. So how many posts are associated with this tag? And for that, we'll say private integer, and we'll call that one post count. And that should do it for our tag response DTO. Of course, we are going to have to configure our mapper to go from a tag entity to a tag response DTO. So let's go there next into our mappers package here, and we'll create a new Java class, and we'll call this one tag mapper. And we'll make that an interface. And let's expand this. So just like for our categories, we're going to put the mapper annotation on the top here. The component model for this one is Spring, unmapped target policy, reporting policy.ignore. So exactly the same as on the category mapper. Now let's add a method here, which is going to return a tag response. And we'll call this one to tag response. And it will take a tag, which we'll just need to import from our entities. Okay. Now, very similar to categories here, we're going to say mapping, and the target of this mapping is going to be the post count instance variable. Source equals posts, qualified by name, and we'll say calculate post count. And this is a method that we are just about to create. So we'll say default, this will return an integer called calculate post count, and it will take a list of posts, which we'll call posts. Let's import list. There we go. Now to the top of this method, I'm going to use the named Mapstruct annotation here, and then call it calculate post count to make sure it matches up here. And now we can go about implementing this method. So first things first, we'll say if posts is null, then we'll simply return 0. Otherwise, we'll say posts.stream, and then we're going to filter out to get only the posts that are published. So we'll say post status dot published equals post dot get status. Let's put that on a new line. And then we simply want the count, which returns a long. We want an integer. So we're going to return, we just cast that to int there. There we go. And that should be enough in order to populate the post count instance variable with the count of the posts associated with that tag. So now that we have our DTO available and a mapper to map it, let's now create that controller. So let's go to the controllers package here. We'll create a new Java class and we'll call this one Tag Controller. And let's expand this. This, of course, is going to be a REST controller. The request mapping for this one is going to have the path of /API v1 tags. And we'll put a required Rs constructor on there as well. So now for our endpoint. So this one's going to be a public method returning a response entity with the value of a list of tag responses. Let's import list. And we'll call this one get all tags. And let's put a get mapping on the top of this because it's going to use the HTTP verb get all tags. Now we're going to need a way to list the tags that we have in the system. So we're going to need a tag service. So let's go ahead and create the tag service in our service layer. So services, new Java class, tag service, and this one's going to be an interface. And let's expand that. Now tag service only needs a single method. It's going to return a list of tags, and we'll call this one get tags. Let's import tag. Let's import list as well. Great. So now that we have our tag service interface, let's go ahead and implement it. So in our import directory, we'll create a new Java class, and we'll call this one tag service import. And let's expand this. So tag service import, of course, implements our tag service. Before we go any further, let's add the service annotation to the top so we don't forget. Let's hover over this red squiggle. Implement methods, get tags. Great. So we just need to implement our get tags method now. The easiest way to do that is to use the tag repository. So if we add a required Rs constructor to the top of the class here, private, final, tag repository, we'll call that tag repository. Great, so we now have our tag repository, we can use it in our implementation. Now we could do tag repository.findAll, but that's not the most optimal way of doing things for the same reason as for categories. So let's just double check our tag repository. Okay, yes, so let's add a new method here, very similar to how we had on the categories repository. There we go. So we just created a method called findAll with post count. We're specifying a query here, and it will do a left join with post. So this will include all of the posts that we need to do our post count. Rather than relying on Hibernate to go one by one and doing several queries, we're doing it in one query here. So if we go back to our tag service import, we can now use tag repository dot findAll with post count to return our list of tags, which means in turn, back in our tag controller, we can now import our tag service, private final tag service, which we'll call tag service. And let's also declare an instance variable for our tag mapper. And we have everything we need to implement our get all tags endpoint. So first, let's call tag service dot get tags, and that will return a list of tags. So let's assign that to a variable called tags. Now we'll convert this to a list of tag responses. So we'll go tags dot stream dot map, and we'll say tag mapper dot to tag response, passing in our tag. And let's just optimize on that. And let's assign this to a list tag response. We'll call this one tag responses. And of course, we'll go to list to get our list type. And now we have a list of tag responses to return. So we'll say return response entity dot OK, passing in our tag responses. And with that, we've implemented our list tags endpoint. So let's restart our application and try it out. So we have an error here, and it's to do with the type of the collection. So rather than a list of posts, it should be a set of posts. And the reason being, of course, is that the tag entity has an instance variable set of posts. So with that change, let's try again. There we go. It looks like the application started up fine. So let's head over to Postman first. So here we are in Postman. So this endpoint should be open. It doesn't have any authentication associated with it. So if we hit this, get API v1 tags, let's see what we get. Okay, great. We get a empty array, which is all we can expect at the moment because we haven't implemented the create tag endpoint. Let's just see this also working in the front end. So here we are in our front end, and we can see the calls to get API v1 tags are returning a 200 OK with an empty array. So everything looks to be working for our list tags endpoint. Building on the list tag endpoint from the previous lesson, we'll now implement the create tag endpoint. So here we are back in our IDE. The create tags endpoint is going to require a DTO, and that DTO is going to represent the tags to create because we're going to support the ability to create more than one tag at a time. So over in our domain package in DTOs, we're going to create a new Java class, and we're going to call this one create tags request. And let's expand this. So as a DTO, we're going to use @data, all R's constructor, no R's constructor, and builder as well. And for the instance variables, we'll say private set of string, and we'll call this one names. And this will be the names of the tags to create. However, just like we did with categories, let's now add some validation annotations as well. We want to make sure that at least one name is provided. So we'll add the not empty annotation here with the message at least one tag name is required. We also want to make sure that not too many tags is provided. So we're going to set a maximum of 10 tags in this request. We can do that with the @size annotation. And as for the actual tag names themselves, let's add 2 annotations. So an @size annotation to say they should be between 2 and 30 characters, and an @pattern annotation, which specifies that the tag names can only contain letters, numbers, spaces, and hyphens. We don't want any special characters making their way into our tag names. So to do that, inside of the set declaration here, put in these 2 annotations, one for @size and the other one for @pattern, which we'll need to import. Again, you'll find these annotations in the lesson notes. So we can see here @size, minimum of 2, maximum of 30 characters, and then a regex pattern here, which specifies that the tag name can only contain letters, numbers, spaces, and hyphens. And with that, we have our create tags request. So now that we have our create tags request DTO, let's head over to our controller. So let's go to tag controller, and we'll add a second endpoint here. This one is going to be a post mapping, public, turning a response entity, which is going to be a list of tag response. And we'll call this method create tags. And of course, it will take a request body, which is going to be a create tag request, the other DTO we just created. And we'll call that one create tags request. Now, in order to create tags, we're going to need to add a new method to our tag service. So let's head over to our tag service and let's add a second method here. This one will return a list of tag, so the tags that have been created. And we'll call this one create tags. And it will accept a set of string, and that's going to be the tag names to create. Let's import set. Great stuff. So let's head over to the implementation. Let's hover over here, go implement methods, click OK, and now we can implement create tags. So we only want to create new tags in the database. So let's check the database first to see if any tags exist rather than try and create them again. So let's head over to our tag repository here. And let's add a new method to this one. This will return a list of tag, and we'll call this one find by name in. And to that, we'll pass a set of string, which is going to be the names of the tags. Let's import set here, put a semicolon at the end. So to this method, we'll pass a set of names, and then the tag repository is going to return all of the tags with the names matching the names that we passed in. So if we go back to our tag service import now, let's call tag repository dot find by name in, and then we'll pass our tag names to that method. And we'll assign this to a variable, which we'll call existing tags. So we only have the tag names to work with as arguments passed into this method. So let's now extract the tag names from existing tags. So we'll say existing tags dot stream dot map, and we'll say tag dot get name. Let's just optimize on that. And we'll collect this into a set. We'll assign this to a variable, and we'll call this one existing tag names. Great, let's put this on some new lines. Okay, so now we have a list of existing tag names. So what we'll do now is we'll filter the tag names passed in, so we only have a set of names of new tags to create. So let's do tag names dot stream dot filter, and we'll say the name, and then we'll say existing tag names dot contains the name, but of course we want it to be, it does not contain the name. Let's put that on a new line. So at this point, we have a stream of tag names that aren't already in the database. So let's go and convert those into tags. So let's map on that. Let's call that name. And let's use our tag builder. So we'll say tag dot builder. And we'll say the name is the name. The posts will be a new hash set. As it's a brand new tag, it won't yet have any posts associated with it. Let's call build. And finally, let's collect. But this time we'll collect into a list. Let's assign this to a variable, which we'll call new tags. And I think we can optimize on that. Great. So we now have our list of tags to create. So these are brand new tags. These don't yet exist in the database. So let's now save our new tags. So let's check first that new tags is not empty. And if it's not empty, let's call the tag repository dot save all, and we'll pass in our new tags. Let's create a variable up here, which will be a list of tag, which we'll call saved tags, which is assign a new array list to that initially. And that way, we'll have our saved tags assigned. And now we can return all of the tags. So we'll combine the existing tags with the saved tags. So let's say save tags, add all existing tags, and then we'll return our saved tags. There we go. And of course, we've made multiple calls to the database in this method. So let's add the @transactional annotation to the top of the method there. And that will make sure that all of these calls to the database happen within the same transaction. So with that implemented then, let's head back to our tag controller and let's look to use our new method. So let's say tag service dot create tags, and we'll pass in create tag requests dot get names, and we'll assign this to a variable, which we'll call saved tags. And now we'll convert our saved tags into tag responses. So we'll say save tags dot map, then we'll say tag, and then we'll call our tag mapper dot to tag response, passing in our tag, and then we'll collect this into a list. We'll assign this to a variable, which we'll call created tag responses. Let's optimize on this while we're here. And we can now return a new response entity, passing in our created tag responses, and we'll return the HTTP status of created. Semicolon there. And with that, we should have a fully implemented create tags endpoint. So let's try it out. Let's start or restart our backend. Okay, that's our backend started up fine. Let's now head over to our front end. So here we are in our front end. Let's go ahead and log in. User@test.com. Password, to which we have no tags listed here. So let's add some tags. So let's go with foo, bar, baz. Let's just clear down our networks panel and then let's click on add tags. Okay, great stuff. Let's take a look at this. Let's pull this up. So we can see here we've made a post to API v1 tags and we have a 201 created. The payload looks good. Names and array foo bar baz, so that matches our DTO. And in our response, we have a list of tag objects, each with an ID, the name, and then the post count of 0 associated with them because they're brand new tags. Wonderful stuff. Let's just pull this down. And it looks like the tags are correctly being displayed on the tags page as well. Wrapping up, the tag management functionality will now implement the ability to delete tags. This endpoint will enable content organizers to remove unused tags while preventing the deletion of tags that are still associated with posts. So here we are back in our IDE. Now we'll not need to create any DTOs for this, so we're going to head straight to the tag controller here. Let's scroll down to the bottom, expand this, and let's add a new endpoint. So this one is going to be a delete mapping, and the path for this one is going to specify the ID. So we'll specify the ID in the path like so. It's a public method, returning a response entity of void type, and we'll call this one delete tag. And we'll add the path variable annotation for the UUID ID. So with that done, we'll now need to add a new method to our tag service to be able to delete a tag. So let's scroll up here, go to the tag service, and let's add a new method, returns void, which we'll call delete tag, and it takes a UUID, which we'll call ID. So with that done, let's now go to the implementation of tag service, hover over here, go to implement methods, okay. And now we have our delete tag stub, which we can now implement. So we'll need to check that the tag isn't associated with any posts. So we'll need to retrieve it from the database in the first instance. So let's say tag repository dot find by ID, passing in the ID. We'll then say if present, giving that the name of tag. We'll check if tag.posts, so get posts, dot size is greater than 0. Let's just put that in an if. And we can optimize on this actually. So we can use isEmpty. So if post is not empty, then we're going to throw a new illegal state exception. And we'll say cannot delete tag with posts. However, if get post is empty, then we can go ahead and delete it. So let's say tag repository dot delete by ID, passing in the ID. There we go. And we'll need to put the @transactional annotation on the top here because we're making multiple calls to the database. And here we are. So we look up the tag in the database using find by ID. If it exists, then we check to see if it has any posts associated with it. If it does, we'll throw an illegal state exception. However, if it doesn't, then we'll go ahead and delete that tag. Now you might be wondering why we're using if present here. Well, quite simply, if we go to look up the tag in the database and we find it doesn't exist, then by definition, delete tag has done its work. There is no tag in the database with that ID. So you could call that a success case. So we're not going to throw an exception for that. So now that we have our delete tag method, let's head back to our tag controller. Let's scroll down here. And now we'll call tag service dot delete tag, passing in the ID there. And then we'll return response entity dot no content. We'll need to call build on that. There we go. So like that, we've deleted our delete tag endpoint. So if we now restart our application, there we go. So that's restarted successfully. We can now head over to our front end and try this endpoint out. So here we are back in our front end and we're on the tags page here. And we've got foo, bar, and baz that we created just a moment ago. So if we clear down our network panel, let's try out the delete endpoint. So let's delete baz at the end here. And click on OK. Okay, so we only have 2 in the list now, foo and bar. So let's take a look at the request here. Let's pull that up. Great. So we've got a delete request being made to API v1 tags with the ID of the baz tag. And we have a 204 no content as the response. And the next call, which is to list the tags, we take a look at the response there. We only see 2, foo and bar. And they are the same tags that we have listed in the front end here. So it looks like our delete tag endpoint is working as expected. Building on our tag management implementation from previous lessons, we'll now create a flexible endpoint for retrieving blog posts. This endpoint will support filtering by categories and tags, whilst ensuring only published content is accessible to users. So here we are back in our IDE. So let's go into our controllers package, create a new Java class, and we'll call this one Post Controller. And let's expand this. And to the top of this class, we're going to add the REST controller annotation. We'll add a request mapping annotation also, and we'll specify the path of /API v1 posts. And we'll also add the required args constructor as well, as we've been using that throughout. And now we'll specify our endpoint. So we'll say get mapping, public, returning a response entity, which will return a list of, and now we need to create our post DTO class. So let's open up our project here. And inside of DTOs here, we'll create a new Java class, and we'll call this one Post DTO. Let's expand this. So to the top of the Post DTO class, we're going to add @data, all R's constructor, no R's constructor, and the builder annotation as well. We can make full use of Lombok because this is a DTO. And now we can start specifying some instance variables. What information do we want to expose for our post? So we're going to want the ID, which is of UUID type. We're going to want a string title, a string content, and we're also going to want a reference to the author. So let's just put a to-do in there, author. We're also going to want a reference to the category. So we'll say private category DTO, and we'll call that one category. We're also going to want a reference to the tags. So we'll say private set of tag, and we use the name tag response for the DTO for tags. So we'll say tag response, and we'll call this one tags. Let's just import set. And then we'll have a private integer, and we'll call that one reading time. And we'll also expose the local date time for created at, private local date time for updated at, and then the post status as well. So let's deal with the author next. And for that, we're going to have to create a DTO to represent the author, which of course is a user entity in our database. So we don't want to expose the full user. So let's open up the project here. We'll go to the DTOs package and we'll create a new Java class, and we'll call this one author DTO. Let's expand this. Now as a DTO, we're going to use the data, all R's constructor, no R's constructor, and we'll have the builder as well. And we'll say private UUID, and we want to expose the ID, and we'll also want to expose the name of the author. And this will allow us to display author information alongside our post. So back to Post DTO, we can now specify a private author DTO, which we will call author. However, looking at this, the only thing that seems to be inconsistent in naming is this tag response name. So I'm going to rename this, and we'll call that one tag DTO. Select all, and then we'll go OK. And in that way, we have a representation of our post now, a DTO that we can use in our presentation layer. So if we go back to Post Controller, we can now specify Post DTO as the type that's being returned. And of course, we'll need to implement a service for this, but let's just fill in the rest of this method to begin with. So we'll call this method getAllPosts. And this method is going to have two request params. So the first one, request param, we'll say it's optional, so required equals false. And it will be a UUID, and we'll call this one category ID. And the second one will be very similar, except for instead of category ID, we'll say tag ID. And these two query parameters will allow us to filter posts based on the category and the tag, or both. Let's just scroll down a bit. So at this point, we need to implement our service. So let's go ahead and do that. So let's open up the project on the left here. Let's scroll down to our services package. And in here, we're going to create a new interface, and we'll call this one post service. And that will be an interface. Let's expand that. And let's define a method which will allow us to return all of the posts which match the category ID or the tag ID as optional parameters. Remembering, of course, that we're only going to return published post to the user. So we're going to return a list of post. This could be pagination in future if we chose to. Let's just import this. But a list will do for the moment. And we'll call this method getAllPosts. And we'll pass in a UUID, which is the category ID, and a second UUID, and we'll call that one tag ID. And that should do for the moment. So let's open up our project on the left here, and then we'll create a new implementation class, and we'll call this one post service impl. Let's expand that. And we'll say that implements post service. We'll hover over the red squiggle. We'll go implement methods. Okay. And we have our method stub. Before we go any further, let's make sure we put the @service annotation on the top of this service. And now we can start implementing our getAllPosts method. Now we're going to need to interact with the database for this one. So let's declare a instance variable of private final post repository. Call that post repository. And then we'll put the required Rs constructor on the top there. And that will create a constructor for us, which means our post repository is injected and available to use. As we're also dealing with categories and tags, it would make sense for us to inject those services as well so we could use them in our implementation. So we'll say private final category service, which we'll call category service, private final tag service, which we'll call tag service. And now we can get to implementing our getAllPosts method. So the first thing that we want to do is check the values of category ID and tag ID. These are optional, so they could be null. So let's check the case where they're both provided. They're both not null. So we'll say if category ID is not null and tag ID is not null, then we want to return all published posts that match both the category ID and the tag ID. So in this case, we only want to return published posts that match both the category ID and the tag ID. And we want to make sure that the proper exceptions are thrown with the proper values in the case that either the category or the tag doesn't exist. So to do this, we'll rely on these services. So first we want to get the category by its ID. So if we take a look at the category service here, we have list categories, create category, delete category, but we don't have get category by ID. So let's implement a method for that. So this one will return a category. We'll call this get category by ID, and then we'll pass in the UID ID. And if we go down to the implementation, hover over here, then we'll go implement methods, get category by ID. We can then implement get category by ID. So we're not going to return an optional category in this instance. We are going to throw that entity not found exception. So we'll delete return null, and we'll say category repository dot find by ID, passing in the ID argument. And then we'll say or else throw, and we'll throw a new entity not found exception. And we'll say category not found with ID. And then we'll say ID semicolon. And let's return this. Now, before we go any further, let's make sure the entity not found exception is handled correctly. So let's go up to project. Let's go to our error controller. And let's double click this. And we'll add another block to the end here. And we'll just swap out entity not found exception in all the cases that the exception class is specified. So handle entity not found exception, entity not found exception. And we're going to return a not found. We'll pass through the message from the exception, and then we'll return that with not found. And this will return the correct error message for when the category or the tag doesn't exist, because we'll be throwing an entity not found exception in both cases. So let's close error controller, and let's go back to our post service import. So now we can say category service dot get category by ID, passing in the category ID. I'm going to assign that to a variable, which we will call category. And now let's do the same for tag. So let's take a look at the tag service. We don't have a get tag by ID, so let's add one. Tag, get tag by ID, passing in the UID, ID for tag. Implementation class, hover over, implement methods, OK. And now we can do a very similar implementation. Tag repository dot find by ID, passing in the ID, or else throw, new entity not found exception. Let's put that on a new line. We'll say tag with, and we'll say tag not found with ID, ID. And because we're already handling that entity not found exception, we don't need to do anything further for this one. Back to the post service import, and now we can get our tag. Tag equals tag service dot get tag by ID, passing in the tag ID. Let's just import tag. Now, bear in mind that exception will only be thrown in the case that something has gone wrong on the UI or somebody is trying to hit the REST API directly, because the UI is only going to display categories and tags that exist, which helps influence why an exception was used in this case. So now that we're certain both the category and the tag exists in the database, we can now go about filtering all posts by that category and tag. And we've got the objects here, so we'll use them. So let's just take a look in post repository. So to the post repository, I'm going to add a new method here. It's going to return a list of posts. Let's just import list. And I'm going to call this one find all by status and category and tags containing. And to that, we're going to pass a post status object, which we'll call status, category object, which we'll call category, and a tag object that we'll call tag. Remembering that we're specifying the post status also because we only want to return published posts. And we're using this naming convention because Spring Data JPA is going to work out the implementation for us because we follow this very particular naming convention, the details of which can be found in the Spring Data JPA docs. So if we copy this, we can now use this in our post service import class, post repository dot the method that we've just created. And we'll pass in post status dot published. I only want to return published post. And we're going to pass in the category object and the tag object as well. And we'll return the results of this repository method call. Now we are making multiple calls to the database in this function, but we're not writing anything. So I am going to add the @transactional annotation to the top here, but I am going to say read only equals true. That's something that's available when you import from the Spring Framework transactional annotation rather than the Jakarta one. So we're covering the case that both the category ID and tag ID is specified. What about when only the category ID is specified? If category ID does not equal null, providing we'll only get to this if statement if the tag ID is null. So if category ID does not equal null, then we'll first do the check to make sure the category exists, throwing the exception otherwise, which will be exactly the same method call up here actually. Let's copy that. And now we'll need to make a call to our post repository. Let's add a new method for this one. Be very similar to our last. Return a list of post, and we'll call this one find all by status and category, specifying the post status of status and the category. Go back to the post service import, and now we'll call post repository dot find all by status and category, passing in the post status of published. We're only returning published posts, and then we'll pass in the category that we've retrieved from the database, and we'll return this. There we go. Of course, we've also got the case when the tag ID is provided and category ID is null. So we'll say if tag ID does not equal null, we'll attempt to get the tag from the database, which will actually be this line here. So either that will throw an exception or retrieve the tag if it exists. And if it does exist, we can use it to query our post repository. And for that, we're going to need a new method, which will return a list of posts, find all by status and tags containing, and then we'll pass in post status of post status, and then the tag. And that will return a list of posts. So if we go back to post service import, we'll now call return post repository dot the method that we've just added, passing in the post status of published and the tag that we've just retrieved from the database. So we've covered the case where both the category ID and the tag ID is provided. So we make sure that both the category and the tag exist, and then we filter all posts, all published posts by the category and tag. Then we have the case where the tag ID is null and the category ID is provided. And then the opposite of that, where the tag ID is provided and the category ID is null. But what happens when both the category and the tag ID are null? Well, we simply want to return all of the published posts. And we can do that by adding a new method to our post repository, which will be the simplest of the bunch so far, returning a list of post, and we'll call this one find all by status, passing in the post status. And now if we go back to post service import, we'll say return post repository dot find all by status, specifying post status dot published. We have a post status rather than post service, and we'll call that one status. And it looks like we've used post status rather than status there, so let's change that. So we go back to post service import. That now looks to be compiling. So now that we have our get all posts service method available, let's go all the way back to our post controller here. And now we'll want to get hold of our post service. So private final post service, which we'll call post service. And now we can use it inside of our get all posts method. So we'll say post service dot get all posts, passing in the category ID, which may be null, and the tag ID, which also may be null. And we'll assign that to a variable, which we'll call posts Of course, we'll now want to convert our list of posts to a list of post DTO. And for that, we'll need to use a mapper. So let's take a look at the project here. Go to our mappers directory, and then we'll need to create a new mapper. So let's create a new class, and we'll call this one post mapper, making it an interface. Let's expand this. So we'll use the @mapper annotation to the top here, specifying the component model as Spring, the unmapped target policy, reporting policy.ignore, and now we'll specify a method which returns a post DTO. We'll call this one toDTO, which accepts a post entity, which we'll call post. Of course, inside of our post, we have our user, so our author, the category, and the tags. So we'll add some mapping annotations to the top here, which says the target, which in this case is author. The source is going to be author. We'll do that for the category, and we'll do that for the tags as well. So we now have our toDTO post mapper that we can use. So we go back to the post controller, private final post mapper, and now we can say posts dot, and we'll do stream map, and then we'll say post mapper dot toDTO, passing in the post, which we can optimize on, and then we'll collect to a list, and we'll assign that to a variable, which we'll call post DTOs. And now that we have a list of post DTOs, all that we're left to do is return a response entity with a HTTP 200 of our post DTOs. And with that, our get all post endpoint should be working. So let's try it out. Let's start or restart our blog application. And that seems to be working. So let's go ahead and try this out. The easiest way to do that is just to go to the front end. So let's head straight there. So here we are back in our front end. And if we take a look at our network panel here, we're making a call to posts, a get call, API v1 posts, that's returning a HTTP 200. If we look at the response, we can see here that we simply have an empty list, which makes sense because we haven't created any posts yet. So it looks like our list post endpoint is working as expected. Building on our post listing functionality from the previous lesson, we'll now implement an endpoint for writers to view their draft posts. This feature will enable content creators to work on draft works whilst only exposing published works to the public. So here we are back in our IDE. So let's head over to the post controller. Let's expand this and let's get to work on our draft post endpoint. So for this, we're going to say get mapping, where the path of that is going to be /drafts. So it'll be API v1 posts /drafts. And that's going to be a public method returning a response entity containing a list of post DTO, not too dissimilar from our get all posts endpoint. But we're going to call this one get drafts. Now, although we're not going to be implementing any proper authorization inside of this application, what we can do is get hold of the request attribute that we are setting in the JWT filter. So request attribute, which represents the user ID. And then we can use that to filter the drafts based on the logged in user. So although there's not any authorization rules to say this user can't view another user's draft posts, by default, this endpoint would filter draft posts to only the logged in user. Of course, there's nothing to stop you from extending this functionality and implementing proper authorization on top of this implementation. So let's get the logged in user to begin with. So let's open up our project here, take a look at our services. And we don't yet have a user service. So let's go ahead and create one of those. New Java class, user service, and this will be an interface. And let's expand this. And to this service, we're going to add a method, which returns a user, which we will call get user by ID. And this will take a UUID, which we will call ID, and that represents the ID of the user. So with the user service interface created, let's expand import here, create a new Java class, and we'll call this one user service import. Let's expand this, and then we'll say this implements user service, hover over the red squiggle, implement methods, okay. And now we can get to work implementing our get user by ID. But before we do, @service on the top there, and we'll also say required arts constructor to allow us to inject collaborators. Now, of course, we're going to be interacting with the database. So we'll say private final user repository. Now, the implementation of this is largely just going to be a pass-through. So we'll say user repository dot find by ID. We'll pass in the ID from the arguments, return this. And to keep things consistent with our other implementations and to rely on our exception handling, we'll say or else throw a new entity not found exception, and we'll say user not found with ID. So you now have a means of getting a user from the database via its ID. So we go back to our post controller, inject our user service, private final user service. We can now get hold of our user service dot get user by ID, user ID. And we'll assign that to a variable, which we'll call logged in user. Now let's implement a method to get the draft post for the user. So inside of our post service here, let's implement a method which will return a list of posts, which we'll call get draft posts, and it will accept a single argument, which will be a user. And let's import user, returning all draft posts for this user. So let's go down to the implementation, hover over here, go implement methods, okay. And now we can get to work on implementing this method. So let's say post repository dot, and we'll need to add a new method to our post repository. So let's head over to there. And let's have this method return a list of posts. And we'll call it find all by author and status. And we'll pass in a user object, which we'll call author, and a post status, which we'll call status. And again, because of the naming convention, we won't have to provide an implementation for this, but we can use it inside of our post service. So we'll say find all by author and status. We'll pass in the user from the argument there, and our post status will be draft, because we're only returning draft posts in this instance. So with that done, we have a get draft post method that we can use in our post controller. So let's say post service dot get draft posts, passing in the logged in user, and that should return a list of draft posts, which of course we can then call draft posts dot stream dot map, and then we can call post mapper to DTO, and then we'll call to list. And that will give us a list of post DTOs, and we can then return response entity dot okay with the post DTOs. And with that, we should have a working get drafts endpoint. Now, before we restart our application, let's just take a look at the Spring Security configuration here. And let's expand this. Let's take a look at our security filter chain. So taking a look at this configuration, the first request matcher to match our drafts endpoint will be this one here, which specifies permit all. And we don't want the drafts endpoint to be permit all. We want it to be authenticated. So I'm going to add a new request matcher before this one here. I'm going to specify drafts, API v1 post drafts, so an exact match, and we're going to say authenticated. And that's going to mean that a user has to be authenticated in order to hit the drafts endpoint. Remembering when you're using this setup, it's the first match that wins. So even though this will match our drafts endpoint, because we've specified this line prior, it means this one will match, and therefore the drafts endpoint will require authentication. So let's restart our application and try out our new endpoint. Okay, that's the application restarted successfully. So let's head over to our front end and try this out. So if we clear our networks panel and then click on draft posts, we can see that requests are coming back HTTP 200 from our drafts endpoint. The front end is passing some additional query parameters in, which is to do with pagination. However, they'll just simply be ignored by our backend. The main thing is that we're calling this endpoint here. And if we go to response, we can see we have an empty list returned. Now, we've yet to confirm that the post structure is being returned correctly. And for that, we need to create some posts. So let's focus on that in the next lesson. However, before we do, let's just make sure that we can't hit this drafts endpoint when we're not authenticated. So I'm going to copy this endpoint here. I'm then going to open up a new incognito window. And then I'm going to paste that URL in. Perfect. So HTTP 403, you don't have authorization to view this page. And that's because we're not providing any authentication information when we're trying to access the drafts endpoint. So with that out of the way, let's get to implementing our create post endpoint. So building on our listing post functionality for both our published post and our draft posts, let's now implement the ability for authenticated users to create new blog posts. This endpoint will enable writers to compose and save both draft and published content with proper categorization and tagging. So here we are back in our IDE. So let's head over to the post controller. Let's expand this and let's get to work on our create post endpoint. So this one is going to be a post mapping. We don't need to specify anything additional in the path. We're just going to use the default path API v1 posts. This will be a public method, returning a response entity, which wraps a post DTO, so the post that was created. And we'll call this method create post. Now, to this method, we're going to have to pass a representation of the post to create. So let's go ahead and create a DTO for that. Let's head to the DTOs package here. And we're going to create a new class, and we'll call this one create post request DTO. And let's expand this. So as a DTO, we can make full use of Lombok. So at data, all R's constructor, no R's constructor, at builder. And now we can specify the information that we'll need to create a post. And we can do this with validation annotations as well. So we'll first need the post title, which we'll use the string type for title. And now we can start adding validation annotations. So we want to make sure that the title is actually provided and it's not an empty string. So to the top here, we'll add not blank with the message title is required. We'll also want to make sure that the title isn't too short and it's not too long. So let's add the @size annotation to this instance variable and a message of title must be between min and max characters. And that should do it for the title. Now let's handle the content, which we'll represent with a string, and we'll call content. Now again, we want to make sure that this is not blank. So we'll add the not blank annotation to the top here. And we'll also add the @size annotation. Of course, content's going to be a lot larger, potentially, than title. So a minimum of 10 characters and a maximum of 50,000. With the message, the content must be between min and max characters. Now we'll also want to know the category to which this post belongs, and we can represent that with the category ID. So we'll say private UUID, and we'll call this one category ID. And of course, we'll want to make sure that category ID is actually provided, not null, so we'll add the not null annotation there. Now we'll also want to know any tags this post is associated with. So we'll do private set of UUIDs, which represents the ID of the tag. And we'll call this one tag IDs #set for the default value. Now, as we are using the Lombok builder, we'll also put the builder default on the top there. However, we'll want to specify a maximum number of 10 tags per post. So we're going to add the @size annotation here with a max of 10, maximum of 10 tags are allowed. Of course, we'll also want to know the status of this post. Are we creating a draft post or a published post? So we'll add a private post status, which we'll just call status. And again, we'll want to make sure this is not null. So we're going to add the not null annotation to the top here with the message status is required. So we now have a DTO which represents all the information we need to create a post. So let's go ahead and use this over in our post controller. So we'll add the @request body annotation, because of course there'll be a JSON representation posted to this endpoint, request body, create post request DTO, which we'll import, and we'll call this one create post request DTO. Now, as only logged in users can create the post, we'll also get hold of the user that's logged in as well, which we can do by grabbing hold of the user ID. And we'll use the user service just like we've done when listing drafts. So we have our logged in user to work with as well. Let's just reformat that slightly. Okay. Now we don't want to be passing a DTO to our service layer. So we need to have a representation of the create post information that our service layer can use. So let's go ahead and create one of those. And that will allow us to create our create post method in our service layer. So we won't put this in DTOs because it's not a DTO, and we won't put it in entities because it's not an entity either. So we're going to create a new Java class in domain, and we'll call this one create post request. And let's expand this. Now to speed things along, I'll implement this and then talk you through it, because we've just gone through all of the instance variables in the DTO, and this will be exactly the same, at least for the initial implementation. So even though we're using this class in our service layer, we're able to make full use of Lombok because we're not adding any JPA annotations to this class. And you'll notice the title, content, category ID, tag IDs, and status are exactly the same instance variables that we have over on our DTO. So now that we have our create post DTO and also a class that we can use in our service layer, let's just make sure we can map between the two. So let's go to project and let's go to our post mapper, expand this, and we'll add a new method on here, which will return a create post request. And we'll call this one to create post request. And it will accept a create post request DTO, which we'll just call DTO. And that's all we need to do for the mapper. Mapstruct can work out everything else. So back in our post controller now, we're able to take our create post request DTO and then use the post mapper to convert that into an object that we can pass into our service layer, which will assign to a variable called create post request. So let's now implement a method in our service layer to create a post. So let's go over to our post service and we'll add a new method here, which returns a post entity, the post that was created, and we'll call this one create post. And this method will need both the logged in user, which we'll use the type user entity for, and a create post request, not the DTO, but the one we can use in the service layer, and we'll call that one create post request. So with that done, let's go to the implementing class, hover over the squiggle, implement methods, click OK. And now we can get to implementing this method. So let's create a new post, and we'll call this one new post equals new post. And we can set the title on this post. So new post dot set title from the create post request dot get title. And let's also set the content, new post dot set content, create post request, get content. We'll also do the same for the status, set status, create post request dot get status. We'll also set the author, and we can do that from the logged in user. So new post dot set author, and that will be the logged in user. The system won't support the ability to create a post as a different user. Of course, you can always extend it to do so, but we'll just use the logged in user as the author. New post dot set reading time. Now we'll also want to set the reading time on the post. We'll calculate that when we save it, and that will save us from having to recalculate it every single time we get the post from the database. So let's just create a very simple private method to do this estimation for us. Of course, you can make this as detailed as you like, but we'll just go with a very simple implementation to begin with. So we'll call this method calculate reading time, and it will accept the string of content, returning an integer. So if the content is null to begin with, or if the content is empty, then we'll return 0 minutes because it's null or empty. It will take no time at all to read. Now let's just get the word count from the content. So we'll say content dot, and we'll trim it to begin with. And then we're going to split, and we'll use a regex for this, // s plus. And then we'll call dot length on that. And that should give us a very rudimentary word count. So now that we have the word count of the content, we simply need to determine what an average words per minute is, and then that will give us the number of minutes it would take to read this content. Now let's just say 200 words per minute is what we're going to use. So let's just create a variable for that. Private, static, final, int, and we'll call this one words per minute. And we'll set a value of 200 for that, which we can then use in our calculations. So we'll say word count divided by words per minute, but we'll want to cast word count to a double. And then we'll do a math.ceil on that as well. And then we'll return that, but we'll cast it back to an int. Again, very rudimentary implementation to get a rough reading time. So we can now use this calculate reading time inside of our create post implementation, passing in the create post request.get content. Now let's assign the specified category to our post. So we're going to use the category service for that. Let's just see if we've got that available. We do, wonderful. So let's call category service dot get category by ID create post request dot get category ID. Again, remembering that will throw an exception if the category doesn't exist, and that's handled for us already. So that will give us our category. So we'll say new post dot set category. And now let's also look up the tags. So let's get hold of those tags. Create post request dot get tag IDs, and that's our tag IDs. Now, if we take a look at our tag service, see what methods we have available, we have get tag by ID, but we don't yet have a get tag by IDs. So let's create one of those. So we'll just return a list of tag, and we'll call this one get tag by IDs, plural. And we'll pass in a set of UUID, and then that will be called IDs. If we go down to the tag service implementation, hover over here, implement those methods, click OK. And for the implementation, we're going to call the tag repository dot find all by ID, passing in the iterable, which of course is our set. And then that will give us a variable, which we'll call found tags. Now what we'll do is rather than just return them, we'll say if found tags dot size does not equal IDs dot size, then we'll throw a new entity not found exception. And to keep it simple, we'll just say not all specified tag IDs exist. And then we'll return the found tags if we in fact find that they all do exist. So now that we have our get tag by IDs, let's go back to our post service, import here, and we're now able to use this method. So we'll say tag service dot get tag by IDs, passing in our tag IDs. We'll assign that to a variable, which we'll simply call tags. And now we can say new post dot set tags to the provided tags. But of course, that will need to be a set. We'll see new hash set, passing in the list there. There we go. So we should have set all of the values, including the category and the tags, and we set the reading time as well. So we'll now say return post repository dot save, and we'll pass in our new post, semicolon at the end. And because we're making multiple calls to the database, we'll put the @transactional annotation on the top of this method. So now that we have our create post method available to use, let's go over to our post controller, and we can now call post service dot create post, passing in the logged in user and the create post request. And we'll assign this to a variable, which we'll call created post. And then we'll use our post mapper dot to DTO, passing in the created post. We'll assign that to a variable called created post DTO, which we can then return in a new response entity, created post DTO, and we'll use the HTTP status code of created in this instance. And with that, we should have the initial implementation of our create post endpoint ready to use. So let's restart our backend. Okay, that's the application restarted successfully. So let's head over to our front end and try this out. So here we are back in our front end and we're all logged in. Before we can create a post, we must create at least one category. So let's go ahead and do that first. Over to categories, add category, and we'll call this category test. And we'll go add. Great, and that's the category created. Let's create some tags while we're here, and we'll call this one test tag. And let's click on add tags. So we have both a test tag and a category to work with. So let's go to new post, and we'll add a title of test title. And now we can add some content. This is some test content. Let's hope we meet the character requirements. And if we scroll down, we can select our category, test, our tag, test tag. And initially we'll put this in draft status, I think. So let's just scroll up to make sure the create post button is available. Let's clear our network panel and let's click on create post. Okay, so let's just take a look. We've got a HTTP 201. Let's take a look at the payload. There's our title, there's our category ID, the content, the draft status, the tag IDs, and the title, test title. And it looks like we've got a response back with an ID, the title, the content's in there, the author object is in there as well. There's our category, there's our tag. We have a reading time of 1 minute for this. And then we have the created, updated, However, post status is returning null, and that might be something that we need to look into. Let's just see if we can see this on our draft posts. Okay, so the status being returned as null looks like a mapper issue, so we may have to fix that later. But it looks like the logic for returning draft posts is working, because here is our test post. If we go home, we can see that although we have our test tag here, we don't see any posts because we've created a draft post. Whilst we're here, let's see if our list post endpoint works. Let's create another new post. We'll call this one test post 2. For the content, let's hope this also meets the character requirement. Let's scroll down. Oh, typo. Let's fix that. Now let's scroll down. Category, test, test tag, status, published this time. And then we'll clear our network panel, click on create post. And we're back on the home page and we see test post 2. So it looks like both our list draft posts and our list publish post endpoints are working in addition to our create post endpoint. So now that we're able to create posts, let's implement the ability to update posts. This endpoint will enable content creators to modify post content, change categories and tags, and toggle between draft and published states. So here we are back in our IDE. So let's head over to the post controller. Let's expand this and let's go about implementing the update endpoint. So we're going to use a put mapping for this, and the path is going to specify the ID of the post. So we'll say public, returning a response entity, which will be the post DTO, so representing the updated post. And we'll call this one update post. So let's first get hold of that path variable, UUID, and we'll call that one ID. Now we'll need some way of representing the update post request. So we'll need to create a DTO for that. So let's open up projects here. Let's go to our DTOs package and we'll create a new Java class and we'll call this one update post request DTO. And let's expand this. Again, as this is a DTO, we can use lombok at data, all ours constructor, no ours constructor, builder, and then we can specify the instance variables that we would like to be able to update. Perhaps with the exception of the first one, which is going to be the ID, because we need to know the ID of the post that we'd like to update. It needs to be an existing post. And we'll put some validation annotations on the top here as well. So not null to make sure that we do get an ID provided. Now we'll want to specify the title. We want to be able to update the title, private string title. And just like on our create DTO, we're going to specify not blank and then a specified size. The endpoint that we're creating is a full update endpoint. So all information is going to be provided each time, even if it's not updated. So we're going to add not blank and then a size on the title to make sure that it's provided and is valid. And now we'll want the content, private string content. And again, we'll add some annotations to the top here. We'll have not blank to make sure that the content is provided, and we'll have size to make sure that the content is in the specific character limits. And then we'll want to know the category to which this post belongs, UUID, and we'll call that one category ID. Again, we'll add a validation annotation to the top here of not null to make sure that we do actually get a category ID. And now we'll specify a private set of UUIDs, and this will represent the tag IDs. There we go, and let's import set. And we'll also put the validation annotation of size on the top here, and because we're using lombok, we'll make that the builder default as well. And then we'll also want a private post status to represent the post status. And we'll put the not null annotation on the top here to make sure that it is provided. So very similar to our create. Let's just see what this red squiggle is. Ah, yes, we forgot to initialize tag IDs to be a new hash set. There we go. And with that, we should have a update post request DTO that we can use. So back over to the post controller, we can now specify a request body, update post request DTO, and we'll call that one update request post DTO. Now, in order to use those validation annotations, we need to put the @valid annotation in front. And come to think about it, let's just take a look at our create endpoint. We've missed it off there, so let's add it in there too. Okay, perfect. So we now have a valid update post request DTO that we can use. But of course, we can't pass a DTO to our service layer, so let's create an object that we can use in our service layer. Let's minimize DTOs, and let's create a new Java class in domain, and we'll call this one update post request. So just like the pattern we followed for our create post endpoint, it will be the same for the update post endpoint. This will be practically identical to our update post request DTO, at least initially. So I'm going to just implement this to save on some time. So here we have our update post request, full Lombok annotations, ID, title, content, category ID, tag IDs, and status. So all of the fields that can be updated on our post, and all are required because this is a full update endpoint. So we have an update post request DTO and an update post request. We'll just need a mapper to go between them. So let's go to post mapper, expand this, and then we'll return an update post request, and we'll say to update post request, passing in an update post request DTO, which we'll call DTO. So we go back to our post controller now. So let's now use our post mapper to convert our update post request DTO to an update post request, an object that we can pass to our service layer. And now we're able to create our update post method on our post service. So we'll head to the post service and we'll specify a new method here. It will return the post that was updated, and we'll call this one update post, and it will take the ID of the post update and an update post request, which we'll call update post request. Now you might be wondering why we're not specifying the user in this case. Well, we needed the user when we created the post. We're not offering the ability to update the user. Now your next question might be, well, why not accept the user and then use that to make sure that the user is only trying to update their own post? And you would absolutely be right. But that's where the scope of our implementation ends. After that point, we start implementing authorization, and we're not going to do that for this project. So we're not going to accept the user for our update post method because we're not looking to update the user to which the post belongs. Of course, you're more than welcome to extend that and implement that if you choose to. So now that we have our update post method declared, let's now go to our post service impl, hover over here and go implement methods and click on OK. And now we can start implementing. So we're going to need to get our post by ID. Let's see if we have a method to do so. We have get all posts. We have get draft post, create post, but we don't have a means of getting a post by an ID. So we'll call straight through to the repository, post repository dot find by ID, passing in the ID of the post. And that will return an optional. So we're going to say or else throw a new entity not found exception, and we'll put that on a new line, and we'll say post does not exist with ID. Let's assign that to a variable, which we'll call existing post. Now, because this is a full update endpoint, we'll simply take all of the information from our update post request and set it on the existing post. So existing post dot set title will be update post request dot get title. Same for the content, existing post dot get content equals update post request dot get content. Status, existing post dot set status equals update post request dot get status. Oh, I've called get content there when I should have called set content. Okay, so we set status. Now let's set the reading time, existing post dot set reading time, and we'll just recalculate the reading time from the content. So update post request, get content, which you might as well assign to a variable, replacing two instances, and we'll call that one post content. Now let's update the category, but only if it's changed. So we'll get the update post request dot get category ID, and we'll assign that to a variable, which we'll call update post request category ID. And we'll say if the existing post dot get category dot get ID equals update post request category ID. However, we're going to say if it does not equal. So that's to say if the update post request provides a UUID of a different category to what we currently have set, then let's use the category service to get that category by ID, update post request category. We'll assign that to a variable, which we'll call new category. And then we'll say existing post dot set category new category. Now let's do the same for the tags. So we'll say existing post dot get tags, And then we'll call stream.map, and then we'll extract the tag ID. There we go. And then we're going to collect that to a set. And we'll assign this to a variable, and we'll say existing tag IDs. And then we'll say update post request dot get tag IDs. We'll assign that to a variable as well. And then we'll say if existing tag IDs equals update post request tag IDs, but if it doesn't equal, then we'll go ahead and update it. So we'll say tag service dot get tag by IDs, passing in the update post request tag IDs, and then that will return the new tags. And then we'll simply say existing post dot set tags new tags. But of course, it will need to be a set, so it's called hash set, passing in the new tags list. And with that done, we can then call post repository dot save, passing in the existing post, which of course has been updated. And then we'll return that at the end. And of course, we'll put the @transactional annotation on top of this method because we're making multiple calls to the database. So we retrieve the existing post from the database. We then go about setting new values on it, taking from the update post request, updating the categories if the category has been updated, and also updating the tags if the tags have been updated. We do this check just to make sure we're not making unnecessary database calls. Just a very easy way to optimize. So with our update post method implemented, let's head back to our post controller. And then inside of our update post method, we can use our new update post method. So let's say post service dot update post, passing in the ID of the post and the update post request DTO. That will give us our updated post. Of course, we're not passing in the DTO, but the actual object that we can use in our service layer. We have our updated post, so let's convert that to a post DTO. So post mapper to DTO, passing in the updated post to get our updated post DTO, and then we can return response entity .ok with our updated post DTO. And with that, we should have our update post endpoint available to use. So let's restart our backend. So that's our backend restarted successfully. So let's head over to our front end and try this out. So here we are back in our front end. So let's head over to our draft post to begin with. And if we click on our post here, we get an error. And that's because, of course, we haven't implemented our get post endpoint. So let's implement that now, and then we'll come back to fully test this. In order to be able to update our post, we must be able to retrieve a post by its ID. So let's implement the get post endpoint. So here we are back in our IDE. So let's head over to our post controller. Let's expand this and let's add a new endpoint. This will be a get mapping where the path specifies the ID. And this will be a public method returning a response entity of post DTO. And we'll call this one get post. This will take the path variable UUID ID, and then we can use that ID in order to retrieve the post from the database. However, in order to do that, we'll need to add a new method to our post service. So let's head there now. We'll add this method to the top there. It will return a post, throwing an exception if the post doesn't exist. And we'll call this one get post, specifying the UUID ID. So we go to the implementation, hover over here, go implement methods, okay. And we can now implement this method. So we'll call post repository dot find by ID, passing in the ID, or else throw, in the case that we get an optional empty, a new entity not found exception, put that on a new line, and we'll say post does not exist with ID, and we'll return that. And now we can use our get post in our post controller. We'll call post service dot get post, passing in the ID from the arguments. We'll assign that to a variable called post. And then we can use our post mapper dot to DTO, passing in the post there. We'll assign that to a variable called post DTO. And now we can return response entity dot OK with our post DTO. Great. So let's restart our backend. So that's our backend restarted successfully. So let's head over to our front end and try out our get post endpoint and also our update post endpoint. So here we are back in our front end. So let's head over to draft posts and let's click on the first post here. Great. Okay. So if we take a look in our networks panel, we can see the call to get posts is returning HTTP 200 and the post object. So let's click on edit. And now let's change this to be updated test title, updated content, and we'll keep the category as is and the tags as is, but let's change it from draft to be published. And before we click on update post, let's clear our network panel, click on update post. We're at HTTP 500. Let's take a look in our stack trace to see why. Scroll up here. We have a validation failure, and it's because the post status is null. So it looks like we do need to fix that post status mapping after all. So let's do that now. So on our post, we have a variable status. Now, if we take a look at the post DTO, expand this, I see we've called it post status. So if we change this to be status and then start or restart our application, great. Okay, so that's our application started up once more. So let's head back to our front end. Let's click on test post 2. And if we take a look at the get post call and scroll down to the bottom, great. So status is now being populated. That's perfect. So if we now click on edit, we'll go update, update, and let's scroll down to update post. Okay. Looks like we're still getting an error of 500. So let's now go back to our backend. Let's look at the stack trace. Validation failed because the post status field is null on the update post request DTO. So there may be a mismatch on the status name as well. Let's just take a look. So it seems to be working for the create, but not for the update. So if we just take a look at the update post request, we're using the variable name status. Now, if we take a look at the update post request DTO, expand this, we're using post status. We change that to be status, and then start or restart our application. That's our application restarted successfully. So let's head back to our front end. So draft posts, let's click on our test post here. Let's click on edit. Let's update the title, updated. Let's update the content, updated. And let's click on update post. Before we do, let's just clear the networks panel. Update post. Okay, so we're back on the home page and we can see an updated post, updated test post 2, updated content. If we take a look for the update post, there it is. So there's our put. We can see the payload with the updated information, and we get a successful response back with the updated values. So in summary then, the errors that we were seeing were to do with the mappings. Because Mapstruct, let's pull this down, go to the post mapper, let's expand this. Because Mapstruct by default would look to match the target instance variable name and source instance variable name, assuming they're the same. And because we used a slightly different name in some of our classes, it was unable to match that up, meaning that we had nulls, and then our validation did its job and was returning exceptions. So now that we have all of the correct instance variable names, everything seems to be matching up and validation passes. So somewhat of an accident, but demonstrates both the validation and the Mapstruct behaviors. So now that we're able to create and update posts, let's add the ability to delete posts. So here we are back in our IDE. Let's head over to the post controller. Let's expand this and let's add a delete mapping, specifying a ID. And this endpoint will be public, returning a response entity of void because it won't have a response body. And we'll call this one delete post. And then we'll specify the path variable, UUID, ID. So now that we have the ID of the post that we want to delete, we'll need to create a new method on our post service to delete posts. So let's head over to our post service and let's add a new method, a void method this time, and we'll call this one delete post. And it will take UUID, which is the ID of the post to delete. Let's go down to the implementation, hover over here, implement methods, we'll click on OK, and now we can implement this method. So now we have a decision to make, and the decision is, what do we do when the post doesn't exist? One option is that we don't do anything. Because the post doesn't exist, delete post has successfully done its job because the post doesn't exist. However, because of the implementation elsewhere in the application, I think it would make sense to throw an exception just to inform the user that the post doesn't exist. And I think that's what we'll do in this instance. So we're going to use get post, passing in the ID to get the existing post. Remember that get post, we go to it, we throw an entity not found exception, which will be handled by our exception handler. So we check to see if the post exists. If not, return the correct exception. And now we can delete the post. So we say post repository dot delete, passing in the post entity. And with that, we've implemented our delete post method. So let's go back to our post controller, let's scroll down here, and then we'll call post service dot delete post, passing in the ID from the path. And then we're going to return a response entity dot no content dot build. And with that, we've implemented our delete post endpoint. So let's restart our application. That's our application restarted. So let's head back to our front end. So here we are back in our front end and we have 2 posts. So let's select the one that we updated. Let's clear our networks panel and let's click on the delete button here. Let's click on OK. Okay, we're back on the home screen and we only have a single post displayed. Let's take a look at this one. A delete call returned a HTTP 204 no content, and it looks like the delete has worked successfully. So we now have our first working implementation of our application. Let's just do a review and discuss where we could go from here and some thoughts. So here we are back in our application. Let's just try out some things to make sure that we're working, and then we can discuss where we can go from here. So let's create a new category to begin with. I'm going to call this one, we'll call this one category 2. I'll click on add. So we now have 2 categories. If we delete that, we can delete that fine, great. So category 2, we can add it back. So categories are looking good. So we've got a test tag here. Let's go with test tag 2, test tag 3, test tag 4, add tags. Great, so we can add multiple tags in there and we can delete some tags. Very good. So categories and tags looks to be working as expected. If we were to create a new post, and we'll call this one new post 3. This is some content. Select a different category this time, perhaps some different tags, and then we'll go straight to published with this, create post. As our new post 3. So if we wanted to try out filtering, perhaps we get category 2. Okay, filtering on category seems to be working as expected. Maybe on tag, test tag 3. Great. Tag filtering seems to be working too. This is part of the test category, but not category 2. Okay. So largely it looks like the application is working. Obviously, this is a first implementation, very, very basic and can be optimized in lots of different ways. So let's discuss where you could go from here. So back in our backend, the first place that you could go from here is obviously writing unit tests for this application. Other than that, if we take a look at our security, this can definitely use some additional work. You might want to enable CSRF, for example. And in our JWT implementation, we haven't implemented things like refresh tokens, which is something that you would want to do in a production environment. What we have gets you authenticated, but then keeping you authenticated with things like refresh tokens would definitely be a good place to go from here. In addition, we have implemented validation in a lot of our DTOs, using these validation annotations. We haven't necessarily handled them all that well on the front end, so that could be improved with helpful error messages. But we have seen these working and triggering when we weren't meeting the validation requirements. So they are doing their job, and that's really good. In terms of our mappers, they seem to be largely working as expected, but of course we did come up against an issue when we were implementing, which a test mapping to and from would have picked up straight away. So tests would be useful for these mappers, but they largely seem to be working as expected. The repository seems to be working, but of course there's a multitude of different ways you can optimize on queries, so that's always worth doing as well if that interests you. And then we have our service layer, which of course could benefit from optimizations, but largely seems to be working as expected, with implementations such as calculate reading time in the post service import being a nice, easy way to extend development. This is a very basic implementation. You can make this as complex and refined as you like. But with all of that said, here's our first implementation of our blog platform built using Spring Boot and Spring Security. Congratulations, that wraps it up for our project. Now I hope you found this truly valuable, and if you have, don't forget to subscribe and ring that bell to be notified when the next project is released. And in the meantime, why not check this out?